Mastering the critical concepts of data analytics requires more than just theory. It's all about applying your knowledge to real-world scenarios. So, we have compiled some of the best hands-on projects to help you build that confidence and take your skills to the next level. Welcome to this exciting video where we dive deep into the world of data analytics. We will cover a range of fascinating topics, from analyzing the Indian education system and food trends to understanding the patterns behind Uber demand, top-selling Amazon books, and even ChatGPT-based data analysis. You will also explore Python projects on IPL, FIFA, Marvel, and Game of Thrones, and dig into critical datasets on COVID-19 and cricket matches. These projects are designed to challenge you, offering invaluable insights and practical experience. Ready to get started? Let's bring your data analytics skills to life. Welcome to this session where we'll be learning regarding data analyst projects. In this session, we will discuss various different projects across the board. First, we will talk about the analysis of Indian education system. Later, the top 10 Indian food analysis will be done, and data analysis for the top 50 selling books on Amazon. The next data analysis project is on Uber. Later, we will talk about how do we do data analysis with the help of ChatGPT. Then, we will explore Python projects on IPL data, FIFA, Marvel and DC characters, then Game of Thrones data. We will also analyze COVID-19 data. At last, we will analyze Cricket World Cup data using exploratory data analysis. In order to understand these projects, you should know certain theoretical aspects. Let's see what are the prerequisites you have to learn before proceeding further. First and foremost thing is on Python programming. You should know the basics of Python, syntax, variables, loops, conditional statements, and functions. Working with various libraries of Python, Pandas, NumPy, Matplotlib, Seaborn, etc. Then you should also have knowledge on data analysis technique, that is data cleaning, exploratory data analysis, data visualization. Optionally, you have to have the knowledge on machine learning basics. If diving deeper into a data analysis project is your goal, you have to have the knowledge on these in theoretical perspective as well. For that, you can watch the YouTube videos on our Great Learning channel.
So now we will have a look at the demo for exploratory data analysis for Indian education system. But one thing guys, I am going to use Google Colab. So basically, let me just show you. Google Colab is nothing but is going from Google itself, providing by Google for AI researchers. If you are an AI researcher, click on new notebook. Your notebook will be there. You don't need to install anything. For the case of any IDE integrated development, if you want to use, that time you have to install Python. But in this case, you don't need to use Python, right? Alright. So yeah, this is all about pretty much about Google Colab. Now we are going to use a particular dataset from Kaggle, Indian School Education Statistics, and we are going to do the EDA on this particular, dataset. So if you want to download the dataset, you just need to go to Kaggle, and here you can see there is a download option. You can directly download it, right? So uploading data in Google Colab, you just need to do one thing. Click over here, right? And from here you will get an option of upload the session storage. So basically this session storage, it will be stay for you for 12 hours. After 12 hours, what will happen? It will remove everything, right? So as it's going to give you GPU and TPU, so GPU and TPU features. So that's why after 12 hours, everything will be deleted by Google. So whatever work you have done or you are going to do in Google Colab, try to save it. right? So here, if you just click over here, it will go to your directory or your local system, and from wherever you try to want to upload your dataset. So these are my dataset I am going to upload, right? So this dataset you will get from Kaggle itself. If you see this, if you just download, you will get all this dataset, right? And we are going to take two particular dataset today. One is we are going to take dropout ratio, and one we are going to take the schools with girls toilet, right? So here we are going to use two particular library for data manipulation, loading the data. One is going to use NumPy, numerical Python, right? This is a pretty much short about Kaggle, you can understand for time being. Now we are going to use one particular function to read a particular data set. So we have a, if you go here, right, here you will see where we have actually loaded the data set. Here you will get an option. Click over here and just copy the path. So after copying the path, if you just need to read the CSV file, you are going to use .read CSV function from pandas, and here you just need to give the dataset path, right? Let me just give that. Yes, for you can see for the variable dropout we actually done. Okay, I did not. So basically I have imported pandas, and after that I have used .read CSV function to read or to understand, to actually go through our comma separated file, which is known as dropout ratio. Now, if you want to see the first 5 rows of your data set, how to do that? You just need to write dropout.head, right? If you just write dropout.head, you will get your data set where you have columns where you have the data. So what are the columns we have? If you want to check what are the columns you have in your data set, that time you can use dropout.columns function. So this is nothing but going to return you all the columns you have in your data set. You can see in my data set I have column called state UT, year, primary boys, primary girls, primary total, upper primary boys, upper primary girls, upper primary total, right? Then secondary boys, secondary girls, and so on. So basically you have the data for each and every part, right? Now, if you want to see what are the null value you have, suppose you need to understand the missing value. So for the missing value, how to do that? There is a function called .isNA function. So .isNA function is basically help you to understand, if you have any null value or you don't have a value for a particular column, right, or a particular row. So it's basically help you to understand that. So in that case, it's going to give you true or false. Okay, so suppose you want to check that is there any null value you have in your dataset. So if you just write dropout.isNA, it's going to give you for each and row and column. But it's really difficult for you to understand, to look at false, false, false. Maybe there are some true, you will just missed it. So that time, if you just write dropout.isNA.any function, that time it's going to sum it up for you. For particular each and every column, it will check is there any null values is there. It's there, then it's going to give you true. If it's not there, it's going to return you false, right? So this is how we can check the missing value in our data set. Okay, right. So what we are going to do now, we are going to do what? We are going to say some of the particular state. So suppose we are going to take a state of West Bengal. I want to store the data for West Bengal from dropout ratio. So in that case, I have taken a variable called data WB, from where we have written dropout, and we have said dropout of state UT equals to West Bengal. So what we have done, if we have any particular state, right? If we have the particular state UT, yeah. So in this case, you can see what I have. I have state UT equals to West Bengal, right? So I have said, hey, if in my column called state UT have equals to West Bengal, then please store all the data in data WB, right? Okay, so this is about when we try to store all the data from West Bengal. Now, if you just want to check what we have got in data WB, so let me write over here, right? So what we have, basically we got three particular row, right? 104, 105, 106, that is state equals to West Bengal, year equals to 2012, 12 to 13, 13 to 14, 14 to 15, and this is the data we get, right? Now if you just try to have all the data, all the data info, and if you just try to understand all the column, like all the column you have, what is the data type for that column, if you just write data WB, what we have dot info. So info function is nothing but it's going to again return you what is the type of your column and is there any null value you have in your column or not. So you can see for all of the cases the data type is object, but I want to have all of them as a float value, because if you don't have the numerical value you cannot do the analysis. That time you can see, if I just look out the dropout primary boys dot values, here this is type of object type, but there are lot of inner values you can see. Maybe when you go for using isany, or you can go for isany.any.sum, right, you cannot see there is any null value. But if you look into the data set, if you go deep in the data set, you can see these inner are nothing but the what, these inner are nothing but these inner are nothing but the missing values. Now you have to replace this inner, because if you want to do the analysis with inner you cannot do that. In that case what you need to do, you have to do just replacing. So we are going to use a function called dot replace function, where we are going to replace inner with 0, right? So basically most of the cases maybe we try to replace the NaN values or the missing values with median, because median is the least affected by the outliers, but few cases we actually replace with 0 as well, right? So in that case you can see we have replaced inner with 0, right? Now we are going to use what, we are going to change this primary boys to what, float, right? So here we have used the lambda function. We have done what, we have written dropout primary boys dot apply. We have used a function called dot apply, where we have written lambda of x. You are actually taking all the like one by one rows from this primary boys, that is x will have, and it will change it to float x, right? So the way actually our lambda function works. The same thing we have done for primary girls, upper primary boys, every one of them. If we have any NaN value, we will replace it with 0, and then we have changed all of them in float, right? Now we are going to do what? We are going to describe our data set. So we are trying to understand what is the description we have for our data set. Now if you just look, if I just write this dropout dot describe, what I have the count of our data set, what is the total count we have, then what is the mean of our data, then the standard deviation for a particular column, then minimum value, right, then 25% quartile, 50% quartile, 75% and max, right? So this is how we have used, like this describe function basically help us to have a good understanding of of the data set. Now if you have a continuous value in your data and if you get minimum value as 0, you can say, hey, the data set is not without null values or missing values, because if your continuous value cannot be 0. So in this case we can have 0, but they are continuous values, but primary boys, yeah, it can be 0. But primary girls, yes, it can be 0. But when you have inner or NaN, that time you can be more sure that you have missing values, right? So this is, now if I just write dropout.info, you can see most of the cases what we got, we have changed our data type for the columns of float 64 or float 32, right? So this is how we have changed the data set, changed the column data type, right? Now, if you just try to understand the count plot, so in this case, we are going to use two more library. Let me just show you. Right. So basically here for, like for the data visualizations, we are going to use two particular library, that is Matplotlib and Seaborn, right? So we have used matplotlib.pyplot as PLT and Seaborn as SNS, right? Now, if we just try to understand the count plot, so we are going to use a count plot from Seaborn, which is nothing but going to group your data. So we are going to use the state UT, whatever the state we have. So according to that, if you just try to understand the count plot for that, so you can see the this is something Bihar, Chandigarh, Delhi, Goa, Gujarat, it's Haryana, it's coming, right? But you have to make a figure size big because it's not going to come. That's why I did not make the big figure size. You can see, but here there is a overlapping. But you can see in the count plot, it's basically grouped the data for Bihar, it's grouped the data for Chandigarh, it's grouped the data for Goa, it's grouped the data for Gujarat, Haryana, then Pondicherry, Punjab, Rajasthan, Sikkim, Tamil, right? For all of them, your data is grouped using count plot, right? Now, if you just look at the bar plot to have an understanding of primary girls versus year, so you can see there is 2013 and 2013, 14 and 2015, there is a hike, right? From 2012-13 to 2014-15. So for the year basis, we can see for the primary girls ratio is actually increasing, right? So girls are coming towards, not the coming, this dropout ratio, right? For primary girls are high, as this data set for dropout ratio for your particular, for the particular data for 2013 to 2014-15, there is a hike that the girls are dropping out school, right? So here we have done the dropout again year for boys. So here you can see the boys dropouts is not that much here as well, right? So yeah, this is how you can understand your data in a more proper way using this data visualization particular part, right? Now, if you just try to understand the data description, or not the data description, data distribution, we used histogram, right? So you can see plot.hist. So we use .hist function to plot a histogram. So histogram we have done to understand our data distribution. For HS secondary girls, you can see this is your data distribution for HS secondary girls column you have in your data, right? So this is something to understand your data. Now if we go and talk about the outliers we have in our data, we use box plot, right? So here also we have used a function called box plot from Seaborn, and you can see for all the columns you have little bit of outliers. If you have this dot, right, you can see these are the outliers of your data set. Now if you just want to get out of the outliers, what you need to do, we are going to use a dot cleave function over here. You can see we have used a dot cleave function, and for the lower range, quartile range, we have taken 0.05, and for the higher we have taken 0.95, right? We have done for all the column, we can see there is a outlier. So after clipping your data, basically nothing but you have clipped your data in a range. So you can see after that, if you just use the same box plot, you can see there is no such dots are there, so it not showing any outliers in your data set. So this is the way we have actually treat our outliers in the data set. But again, it's a basic note, not all the cases we try to manipulate our outliers, right? Yes, so this is all about pretty much about the EDA we have done so far, and we try to understand that what is the dropout for the girls for from the 2013 2014 15, and also we have understand few statistical terms about the being a data scientist to do the exploratory data analysis. Now we will do the project on EDA for top 10 Indian food analysis. So we have used this dataset from Kaggle itself. So in this dataset we have few things, right? So why we are talking about the dataset? So maybe now we are not going to use any machine learning technique, but in the dataset itself you can see there is a continuous type dataset. We have discrete type dataset, right? So when we have continuous type dataset, that time what is the problem? Not the problem, that time we need to use different type of machine learning algorithm. When we have a discrete type dataset, we need to use different type of algorithm for machine learning. So you have to understand those things. Let me just show you what is the dataset all about. We have the dataset called Indian 101, the dataset name, which is taken from Kaggle. It's an open source dataset. Here we have the name of the food, that Balushahi. Ingredients we have maida flavor yogurt. Diet, that's what type of the data, like what type of food it is. It's a vegetarian food, it's a non-vegetarian food. And then we have preparation time, how much time it will take to get prepared. After that we have cook time, right? What is the total time of cook time, right? So this is the cook time. And then we have the flavor, it's sweet or sour or spicy, right? These are the thing we have. Now we have the course. Course is nothing but the type of the food. It's a dessert or it's a main course. What is it? Then state, from where it's belonging. It's from West Bengal, right? So it's a Bengal food, that Balushahi. Okay, and the region is East. So these are the thing we have in our data set. Now you will ask me why you are actually like showing me the whole raw data, because before start with any data set, you have to have idea about your raw data. If you don't have your raw data, then you cannot understand you cannot understand this whole total project, right? So here what we are going to do. So here we are going to use Google Colab. So now we are going to see that what is the data set all about. So basically in this data set consists about 255 Indian dishes, right? I am very foodie, guys. So yeah, I love to see this these dishes and trying new foods. So yeah, so you can see. So if you don't know about, Hitesh is saying I don't know. Alankriti is saying I don't know. Okay, so if you don't know about Google Colab, let me just walk you through on that. Just write Google Colab. Right? So this Google Colab is given by Google for AI researchers, and basically it's help you with lots of features it has. Like for now timing, you don't need to go for doing lots of things, but yeah, this basically going to help you with lots of features if you work with a very high computational power artificial intelligence project. Right? So in this case, you can see this is something written as new notebook. You just need to click over there. Your notebook will be ready. You don't need to install Python. You don't need to install any integrated development environment, which is known as IDE. Right? You can directly start up with the project itself. Right? So this is pretty much about Google Colab. So I have done my notebook over here. You can, if you want to put some text, you can. Right? So the data set we can see we have 255 Indian dishes and 9 columns associated with each of them. So the 9 columns are name of the dish we have, then main ingredients used to make those dish. Then we have diet. Diet is nothing but you are a vegetarian, that the if you are a vegetarian, you go for vegetarian foods. If you are non-vegetarian, you go for the non-vegetarian food. So in this case, we actually can see this sweets are nothing but the vegetarian. So you can see the preparation time, the total preparation time to make that particular dish made. Then cooking time. What is the cooking time? Then flavor profile. Flavor profile includes whether the dish is spicy, sweet or bitter or what. Then we have course. Course of meal. It's a starter, it's a main course or it's a dessert. Right? And then from which states it's belong to. Who is like where this dish originated. Then we have the region where the states belongs. Right? These are the 9 columns we have in our data set. Okay. So now what libraries we are going to use? We are going to use Pandas, NumPy. So Pandas we use for data manipulation. We know this Pandas actually used for data manipulation tool. Right? So in this case, we are going to use Pandas library. We are going to use NumPy. We are going to use Plotly. So Plotly is basically used for data visualization. And we also use Matplotlib. This is also used for what? This is used for basically again data visualization, right? So now after I did that, I just need to read our data. So you can see, if you want to read your data and if you want to upload your data in Google Colab, just click on this particular sign, right? Click on this particular sign. After that, there is an upload option you will get, right? Let me make it little big. This is the upload option you will get. Click on the upload option and it will directly go to your local system, and wherever you have the .csv file, you can directly click on there and just click on open. It will be automatically redirected or automatically uploaded to Google Colab. After that, if you want to see the path option for that, in the 3 dots, if you click, you can see the copy path option. So now you'll ask me, why do we need it? So when we are going to use this .read CSV function to read our data set and to store our data into a variable, that time you have to go for giving the path for your data set. So in this case, you can see we use pd.read CSV to read our data set. That is from pandas. Now, if we just write data, right? So this data is nothing but your data frame, and in the data frame you can see your data is already loaded. You have the name, ingredients, diet, preparation time, cook time, flavor profile, course, and all those things you have, right? Now if you just want to see, hey, I don't want to see all the data, I just want to see the first 5 rows of our data. How to do that? You just need to write data.head. So data.head is basically used for what? Data.head basically used to understand or to have first 5 rows of your data set. So if you just write data.head, you will get first 5 rows. You can see from 0 to 4, the first 5 row you get. Actually, you can see these are the first 5 rows. Now, if you want to check, I have said that we have 9 columns. But if you say I want to see the 9 column, what are the columns we have in our data set? In this case, so some data.columns. So data.columns function is used basically to see what are the columns we have in our data set. Now, if you want to see the information about your data, what is information? What is the data type for your particular all the columns? Is there any null value? So what is the total null value you have? Null value is nothing but the missing value you have. So in this case, we use a function called .info function. So when we use this data.info function, you can see for the name column, you get particularly no null count. So the none null count. So basically you don't have any null value, right? So now if we want to check this in a more precise way, we need to use one more function which is known as .isNull. So basically when we try to write data.isNull .any. So if I just write data.isNull, this is basically going to each and every column and rows and try to find is that value is a null value or it's there some value is there. So if you just write it, you will get a boolean return from this particular function for each and every rows and columns. But I don't want that. I want to see for each and every column, right? Not for each and every row. I just want to see for name, ingredients, dish, and preparation time. Do I have any null values? So in this case, we are going to use .any function, right? So in this case, when we try to understand is there any null value, so in this case, you can see we have false, false, false and true for region. So there is null value in region. For other cases, according to the function, they are saying there is no null value. But trust me, we do have null values. I will show you on that. And if you want to check, .any is basically going to give you boolean result. And if you want to see what is the total number of null value you have, particularly for all the column, you have to use .sum function. Right? So for the region, you can say only one value you have, that is null value. Right? Now, what I have. Now, if you just go back, you can see we have -1. So these -1s are nothing but your null values. But when you use .isNull function, it's not going to show you because there is a value. It's going to check is there any value or not. There is a value. That's why we have to take care of those things as well. So in this case, what I have done, I said if I have -1 in my data set, please replace with np.nan. Alright, if I just write data.replace -1 np.nan, that time what we need to do, it's actually going to replace all the -1 with nan, because they can say this -1 are nothing but your missing values, right? So maybe your -1 in a number or is in a string. You can see that's why I have used twice, that data dot replace -1 and data dot replace -1 in quotation, right? If I just execute it and if I just write data dot head, in this, do I have any nan value? No. But in this case, if I do the same thing, the data dot is null dot sum, the same thing after replacing -1 with nan, you can see for the state we have 24 null values. For region, we have 14 null values. So you do have null values or the missing value in your data set, but you have to understand that, right? Okay, now if you want to check the shape of the data, what are the type, how many columns you have, how many rows you have. In this case, you are going to use data dot shape function. You can see you have 2555 and 9. So 2555 rows you have and 9 columns you have, right? So now if you just try to understand that the proportion of vegetarian and non-vegetarian dishes. So in this case, guys, can you please let me know who are here are vegetarian, who are here are non-vegetarian, who loves to have vegetarian food, who loves to have non-vegetarian food. In the meantime, we will do this data analysis. All right. Okay. So now what we need to do, we are just going to use this particular. So we have data, right? And then we have called the column name called diet. Then dot value counts dot reset index. So basically we try to take only the data for diet, right? For the diet, and we are also taking the count of it, right? The total count of it. Okay, so now if I just write pie dot data columns diet and count, and if I try to use a pie chart, right? Okay. If I'm trying to use a pie chart for vegetarian and non-vegetarian, we are going to use px.pie function, right? And here you can see it's already there. For vegetarian, it's green. For non-vegetarian, it's red. So we can see the diet vegetarian count is 226 out of 255 and this is 29. So we can see the majority dishes we have in vegetarian, right? So yeah, so now we will see one more thing. We will look into that what the dishes are going to take the most highest time, right? So in this case, how to do that? So do that, we are going to do few things. Okay, so here we are going to make a variable called cooking time. So cooking time is equals to, we are going to take two different columns from our data set. One is cook time, one is the name of the data, the name of the dish. Right? If I just write cooking time dot head, you can say we have the dish name with the total time it takes to get cooked. Right? So we have bundi, we have gajar ka halwa, ghevar, we have gulab jamun. Right? Okay, so in this case, what we are going to do, we are trying to sort our data. So whatever the data we have, we try to sort our data in an ascending order. So basically the first top 10, right? We are going to take the first top 10 dishes. We are going to take a less time, right? We are going to take the less time to get cooked. So in this case, what we are going to do, we are going to use we are going to take dot head and then tail. Okay, now we are going to use the bar plot to see that. So you can see this is something lassi pani puri, right? This is the cooking time name, this is the cooking time, right? So this is how you get your data for top 10 which are actually taking less time. And if you want to see what are the data is going to take the the most time, that time you can actually use dot short values, but the ascending equals to false you need to write. So basically your data will be in a descending order. So if you take the first 10 data, it will actually show you what are the data is actually going to take the highest time. So in this case, if you do the plotting over there, you can see Srikhand, biryani, they are actually taking high time to get prepared. Thank you guys. Thank you so much for being with us. Now we will do the demo on Amazon top 50 selling books. I'm going to use Google Colab for this particular one. This particular Google Colab ID by Google for AI researchers, and you will get lots of features on Google Colab. Right. Okay, now I will show you how can you actually import your data. So in order to import your data, and let me show you from where I have taken this data. So if you just write Amazon top 50 best selling books data analysis, if you click over here, right? Can you see there is a download option? This is from here we have taken this particular data set. Now, if you ask me how to do that, if you go and check this box, right, there is a box option is here. If you just click over here and there is an option, this is a file with arrow, right? If you click over here, you will get an option to upload it, right? So if you want to upload, can you see? I have uploaded my data set from here, bestseller with categories, right? Yes, this is how we can actually upload your dataset in Google Colab, the way I have done for bestseller and categories.csv. Right. Now what we are going to do, we are going to import pandas as PD, which will actually help us to what this pandas is a data manipulation library, and it will help us to manipulate our data to load our CSV file. It's a quick question from all of you. What is this particular CSV? What is the full form of CSV? Because for a long time I am saying this is a CSV file. The dataset is basically in CSV format. Yeah. So this CSV file, you can use CSV file and you can actually read CSV file using pandas. There is a function called .read CSV. Yes, .read CSV basically will give you, opportunity to read a .csv file. Now I will show you few things you have to remember, right? Can you see I have my variable called data, and then I have written pd.read CSV, and you have to give the path for your data set. But where will I get the dataset path? I have shown you how to upload it. So after you upload this, if you can click on this 3 dot, you will get a copy path option. Just click on there, your path is copied. Now what you need to do, go here, right, and then paste it over here, right, Control V. Okay, so this is how actually you will get your dataset path. Now, as we have already read our CSV file, now I want to see is my data already read by read CSV function or not. How to do that? I am going to use data.head function. Why do we need to use data.head function? This head function is basically going to give you, or you can say return you the first 5 rows of your data set, right? Suppose if you just write data.head, you will get this. You will get 0, 1, 2, 3, 4, 5. You can see name, author, user rating, reviews, price, year, and genre you have. Now you can see we have done data.head. Now if I want to give you a quick understanding of data, what we have in in order to the columns we have name, which name is like name of the book, which is in string format. Then we have author, the author of the book again, which will be in a string format. Then we have user rating, Amazon user rating, which is in float. Then we have reviews, the number of written reviews on Amazon, that is again in the float. Then what is the price of the book we have, right? So suppose what is the price you have, and then you have year, right? The year is ranked on the bestseller, date, and genre, whether is a fiction or non-fiction, that is again in string. So this is pretty much about the dataset description. Now if you want to see, do you have this dataset columns? What are the columns you have in your data? In that time you can write data.columns. This data.columns will actually return you what are the columns you have in your dataset: name, author, user rating, review, price, year, genre. You can see, and the type object, right? So dot columns will return you what are the columns we have. Now if you want to see what are total columns you have, what are the total rows you have, that time you need to use a function called dot shape. So data dot shape will give you first the number of rows, that I have 550 rows and 7 columns, right? Now, if we can go for data.describe. So this data.describe, you can understand the basic of stats. Total count, you have the total count of rows you have, then what is the mean for each and every column you have, which is not string again. Then you have standard deviation to understand your data more. Then you have IQR, interquartile range, which is again comes under stats, right? Now, if you want to see all of them, you can see them in the function called data.describe. Now, if you want to see what is the info, as I have said, name is string, then I have said author is string or object. Now you will say, how can I actually believe you? So in this case, you can directly write data.info. It will return you all the type of the data, all the type of the, column you have, what is the data type they have for each column, right? Okay, now we are going to talk about, do you have any null value? What is null value? Do you have any column or any rows without any value? Do you have that? Okay, so in order to check that, we have to use a function called data.isNull. So data.isNull is basically going to give you an idea. Now you can see we are going to use isNull function and then .any function. So basically, why we are using .any is basically it's going to check for each and every like the data we have, that do we have okay, so do we have any null value, right? How to do that? You can see for author it's false. For all the column we have, we do not have any null value which is not present, right? And if you want to check .sum is again, it's going to give you the summation of total null value. Now we are going to import Seaborn and Matplotlib, right? So we are going to use a heat map. Why to use heat map? Heat map is going to give you the correlation between the column you have, right? So yes, this is something for now you can understand. We use heat map for that, right? Yes, Rana, there is no NaN value, right? Now we will talk about outlier detection. So outlier are extreme values. Suppose we were talking about someone is going to do a transaction for a huge amount. It is nothing but an anomaly or a outlier or the error, right? Outliers are extreme values that deviate from other observation on the data. They may indicate a variability in a measurement or novelty, right? Experimental errors, you can say in one word, that is outlier. So we use box plot to understand, do we have any outlier in our data, right? Okay, so in this case, we are going to use plt.subplot and .boxplot. This .boxplot is basically going to show you, do you have outliers? If you can look into this part, you can see these dots are nothing but your outliers. Yes, you do have outliers, that is nothing but your errors. Now, how can you actually handle these outliers? So in this case, you can just replace this, you can just use a clip technique. So this clip is something called, if you will clip your data with the lower range and the upper range, which is nothing but 95 percentile, right? Yes. So this is how you can actually handle the outlier. And we are going to use numpy.clip, right? We are going to write data for each and every column. We are going to clip our data. After we clip our data, if I do the same box plot, you can see there is no such dotted and we have removed our outliers. So there is no such errors we have in our data, right? Now we will try to understand using clown plot that explore the trend over for each genre, number of best selling books in each year. How can you do that? So we are going to use a plot called count plot. So now you can see what we are going to do. We are going to write sns.countplot x equals to year, as we are trying to understand the best selling books in each year, right? X equals to year. data equals to data, and U equals to genre, right? As we want to understand by genre basis for each year, right? Now, if you just do that, can you see what we get for 2009, for 2010, right? And in the end, what we have, this is for this orange is for fiction and this for non-fiction, blue one is for the non-fiction, right? Yes. So this is how you can use count plot to understand the number of best-selling books in each year, right? Yes. So what we have done, the number of best-selling books in each genre each year. What is hue? So basically, you can see it has done the count based on your genre, right? So sorting like you can understand in a simple word, we are actually sorting the data, right? What is genre? It's fiction or non-fiction books, right? You can understand what is fiction and non-fiction book. Yes, this is something called genre, right? Yes. So this is something we can do this count plot, right? Yes. So these are the basic data visualization you can do and also do this data analysis, right? So what we will do, first we are going to import our library. So we are going to use pandas for the data manipulation, and we use ASPD as an alias, right? It's an alias for pandas. We don't want to use pandas every time. So in that case, we are going to use ASPD. And we are going to use linear regression model we will get from the scikit-learn library. So from scikit-learn, that is sklearn dot linear model, we are going to use linear regression. So you don't need to put logistic regression, you can just remove it, and we are going to import linear regression. We are going to use NumPy for the mathematical calculation. We are going to use matplotlib for the data visualization, and Seaborn is also for the data visualization, right? So let me just do that, execute that. Okay, we have already downloaded. Okay, so we are going to use two data over here, that is weather.csv and cabrights.csv. So to fetch the data from Dropbox, what we need to do, we need to use wget function, right? That's all you need to do. Your data will be fetched, and the amount of the data is big. We are going to use two data CSV, right? So the amount of the data is actually a huge data. So in that case, we are going to use a memory saving function that is also taken from Kaggle. So we are going to use that, will actually reduce our data size. So we have already defined a function that is def reduce memory uses, that is taken from Kaggle as at will. Okay, so let's see how can you take the data. Already we have fetched the data from the Dropbox, right? Now what we need to do, using .csv function, we are going to like store our data in a variable. So first we are going to store our data in a cap data. So our variable name is cap data, and then we are going to use pd.read csv, and then you need to give the path of the data. For my path is content and cabrights.csv, right? And then we are going to use reduce memory uses function, which is actually going to show how much it reduced our data set. Okay, then the same thing with the weather data as well. Let me just execute that. So you can see our data was for the first data was 52.88 MB, and it is decreased by 15%, and now it's 44.95, right? And for our weather data was 0.38 MB. It was not that big, but it was also decreased by 43.7%, right? Now let's see what data we have. So get the first 5 rows from your data. We use .head function, right? So we already stored our cap data in cap data variable. Now I am just writing .head. It will just give me the first 5 rows of my data. So I got first 5 rows. So what we have, let's have a look at what are the columns we have, right, for cap data. So first, I told you, first you need to understand your data very well. Okay, So let's see what are the columns we have. Okay, so first we have columns like distance. What is the distance they are traveling? Cab type. What is the cab type? We are using Uber and Lyft. Lyft is basically a American based company. Okay, then we are having timestamp. What is the timestamp they are traveling? The destination and the source for like particular user. Then we are getting the price, and we get surge multiplier. We used to see some of the time in the cab application that the surge is actually, it's because of the high demand, the surge is actually added, right? So in that case we will get the surge multiplier. We are going to get an ID for each and every entries in the data. That is actually required to understand how many like distinct data you have, not the repeated data, right? And the product ID and the name, right? These are the columns we have in cab rides data. Okay, fine. Let's see what we have in weather data. So to get the columns, we use columns function. So it will return all the column you have in your data set. In weather, we have temperature, we have location, clouds, pressure, rain, timestamp, humidity, wind, right? So basically this helps us to understand maybe in the rain, the price of the cab is maybe high, or maybe if it's the weather is fine enough, so the price will be not that high, right? So for that we are going to use these attributes over here, right? So before start the any analysis, we need to change our timestamp into date time, right? We need to have a, like, before that timestamp is a string, but if we have using string on timestamp, we are not able to get the proper date and the time from that, right? Maybe in the best of time, maybe in the best of date, the price varies, right? Maybe we don't have idea that what actually our how our attributes are related to each other. For that we are going to use dot to date time. It's going to convert a string to the date time value, right? So we are going to use from pandas pd dot to date time, and we are going to pass the column, particular column in the cab data, that is timestamp. And the same thing with the weather data as well. We have a timestamp in weather data, we will convert into date time. Okay, fine. So let me just execute that. Okay, so now we are going to check the shape of the data. For the shape of the data is basically how many rows we have, how many columns we have in the data, right? So we are going to use dot shape function. Let's see. So we are having 693071 rows and 11 columns in cab data, right? So let's see for the weather data, what we have. For the weather data, we have 6276 rows and 9 columns, right? So if you want to check your data shape, you can go for using dot shape function, right? Now we are going to use dot describe. So dot describe is basically it's a basic part or the initial parts of exploratory data analysis. We use dot describe to understand the standard deviation of our data. What is the count we have in the data? How many data we have actually? We get the IQR, interquartile range, that is 25%, 50%, 70%. So these are the concepts of stats you will get, right? Okay. So fine. Let's see what actually we have for particularly cab data. So you can see for the cab data we have almost 693071. These are the total rows we have, right? So we have mean for each of the column, we have standard deviation, we have minimum, and interquartile range for 25%, 50%, and 75%, right? Okay. So for the weather data also, we are going to see the describe. So you can see count, mean, standard deviation, mean, all the things we get for weather data as well. This actually helps us to understand our data more intuitively, right? If you don't understand your data, how can you do modeling, right? Okay. Now as we have the two data, now we are going to use dot concat function. Dot concat function is basically used to join two data frame, you can say, right? So I have two data frame. One is cab data, one is weather data. I just want to join them. So to join them, I am going to use dot concat function. Okay. So you can see, let me just do that. and just let me print it. So I'm going to use, so yes, we are going to use dot head function to get the first 5 rows from the, so yes, you can see I got my A. So A is basically the combination of cap data and the weather data. You can see, right? This we got. Okay, right. So now we are going to see that we are just going to make a column for day. So I just want from timestamp what's the particular day it was or what's the hour it was, right? For date time, Python provides us a function that is dot day that actually help us to get the day from the timestamp, and they actually provide hour function as well, which provides us the hour, like at what particular hour it was in the timestamp, right? So these are the actual flexibility with Python when we go for using Python, right? So you can see, yes, let's see what we have in that. So let me print a dot head, right? So what we get in the day and in the hour, right? Let's have a look at that. So let me just, okay. So for the, okay. So most of the cases it is NaN. So we need to understand that how can you solve that NaN value as well, right? So we can't go with the NaN value because it will going to affect our model, right? So when we are going to use dot tail, you can say it will give me the last 5. Okay, so last 5 column of my data set. So you can say in the day we get some of the values over here, that is day 1.0, 1.0, 1.0 and 1.0, right? So this is how we are going to use dot day function or dot hour function, right? So now as you see, there are lots of NaN values we have in our data set, right? So we cannot go with so many NaN values, right? So in that case, what we need to do, we need to use dot fill function. So dot fill function is basically give you that 0, like dot fill is basically going to fill your NaN values. So I want to fill my NaN values with 0. So I'm going to write 0 and in place equals to true, right? Right, it's going to take a little bit of time. And then we are going to see our data, e dot head. So I have just shown you the basic how can you go for data manipulation, but trust me, what you need to do to go for a good data manipulation part, you need to you need to add so many things. These are the basic things, right? So you can see whatever the NaN value I used to have, it actually converted with 0. So day and hour becomes 0, 0, 0, right? So this is how you can remove NaN value from your data set. So let's see what are the columns we have in A. So we have column like distance, we have column like cap type, timestamp, destination. These are the column we have after concat your 2 data frames, right? Now we are going to use group by function. Why we need to use group by function? So basically group by function is going to return you the group based on the column you have provided. So I have cap type 2, right? One is Uber, one is Lyft. So I want to see how many data are from Lyft and how many data are from Uber, right? Fine. So let's see after group by what we will get. I said I want to group by cap type. So I have a cap type Lyft and Uber. In that case, I am going to see how many count. I want to see dot count, right? How many data we have for Lyft, how many data we have for Uber, right? So you can see I got 307408 for Lyft and Uber. For Uber, I have 385663, right? So this is the way we are going to use group by. So group by is used for that. And I want to visualize my data. How can I just want to see a bar plot? So using bar plot, I just group by my data according to cap type. So I said a dot group by, and then I have provided the which column, right? For cap type, I want to do that. So cap type and dot count, the same, it will going to give me the count of how many cab we have for Lyft and we have for Uber. And then I'm going to plot bar plot. To plot the bar plot, what we need to do? Use dot plot and dot bar function. Then you will get the data set like this. You can see we get different color for different attributes. For distance we have blue, for timestamp we have orange. This is like this, and this is for Lyft, and this is for Uber. So you can see in the like in the visualization, Uber is high because we have high number of data for Uber, right? Now we are going to see that price. What is the price we have, right? What is the fluctuation of price we have? For that, what we need to do? We need to specify the column. So for A, price is the column, and then dot value counts. What is the value it has? And dot plot, and I want which type of a plot? That is bar plot, right? So you can see we got it, right? It will take some time because of the data set. Yes, you can see this is the plot we got for price. This is the fluctuation we have in the price, right? Okay, and if we want to see which hour is the peak hour for the cab, right? So I want to see which hour is the peak hour. So for that, I'm going to use our column, right? Okay, so I'm going to use our column and then the value, and then again I'm going to plot bar plot. Let me just execute that. So here I'm just going to use a dot plot function normal. So I want to see how price and hour is varies with each other, right? So I'm going to use dot plot function for that. So in the X, I took the hour. In the Y axis, I took the price. Okay, and I'm going to plot that using X dot comma Y, right? And again, I want to see if it's rain. What's the difference? What's the connection between rain and price? Again, I'm going to plot them, right, using the same value. Okay, right. Now we will see how can we actually make our model. Now there comes the basic interesting part. How can you make your model? So for my case, I thought maybe distance, temperature, cloud, pressure, humidity, wind, rain, day, hour, surge multiplier, and clouds. These are I use clouds twice, so I can remove that. Okay, so these are the main attributes for my data to train my model, right? So in that case, I want to use this data. Okay, so this data will be my training data, and my label data will my price, right? So this is the label data. This is the supervisor for supervised learning, right? So let me just take that. Okay, so in X1 we have all the columns, and in Y we will have only the label we have for the data, right? And sklearn is basically a scikit-learn library where you can use all the machine learning that's already predefined, it's written in from the scratch. You can just need to call the function for that, right? Okay, now we are going to use train, test, split. So this function is used basically to split your data into training part, into testing part, right? I have a data, but I just don't want to put all the data to my model, right? I want to give a specific maybe 80% of the data for training and 20% data for the testing, right? So I gave my X1 and Y1, and test size I gave 0.25. I mean 85%. Yes. So 75% of my data will be test data, train data, and 25% will be my test data, right? Okay, and we use random state equals to 42 is basically just it will take the data randomly. Okay, now we are going to call linear regression function. So calling linear regression function, you just need to write linear regression and then the bracket. This is how you can call the linear regression function. And you need to you need to actually train your model using dot feed function, and I'm going to provide xtrain and xtest data for my model to learn. You can see my model is already learned, right, from the xtrain and xtest. Xtrain contains all the attributes and xtest has the price, right? Now I'm going to see the prediction. What is the prediction for my model? Okay, fine, let's see. Okay, so let me just print it, the prediction for you guys. So this is the prediction. This is the array we got for the prediction. Let's see what is the actual and what is the predicted value, right? So for that, I'm going to create a data frame calling pd.dataFrame, and then we are going to write the name of the column, that is actual. Then we are going to provide the actual value, that is y test. and the predicted one, that is already comes under predictions, right? Now we are going to see that. So you can see actual is 42.5, predicted is showing 32.54. Our model is good but not best, right? So we can, now this comes the part of fine tuning. How can you tune your model? So here you can see I got 13.5 is the actual and the predicted is 15.51, right? And here you can see the actual is 7.5, right? And there is predicted is 10.70. So you can see our model works pretty well, but if you want to make your model more perfect, you can go for using some fine tuning techniques, right? Right, now we are going to see the visualization of how can we actually our predicted and actual value works. For that we are going to use grid function, right? And we are going to use plot. So here I said, if our model is actually in the blue, they are the actual, and what are in the orange, they are actually the predicted. So see the graph, guys. You can see this is the actual, this is the predicted. In here my model is not working pretty well, but here you can see our model is working pretty well. There is a very few difference between these two, right? So yeah, this is our actual graph according to the actual and the predictions, right? So this graph is basically showing what your model is predicting, the price your model is predicting, and what is the actual price, right? So this is basically showing that what's the actual price and what's the predicted price. Okay, you can see I use Xtrain and Xtest because Xtrain and Xtest is used. Xtrain have all the attributes and Xtest has the price, right? So this is why we used these two part of the data to train our model. Thank you so much, guys.
Under that process is how to load the data set, and we'll understand about the whole data what we will going to analyze. Before we do that, first we'll click on upload file and then we'll upload the data set. So here our data set is car MPG. We don't know as of now what is basically this car MPGs and what is all about. After uploading the data set, we're going to understand by using the prompt. We're going to ask ChatGPT a few prompts. Based on that, we'll get an output. So first prompt we're going to enter over here is, so as you can see here, we have uploaded the data set. Now we'll understand about this data first. So before that, we're going to enter a prompt. Here we are giving a prompt. The prompt is basically what we want to know through ChatGPT, what we want to understand through ChatGPT. Here we are asking that load the car MPG data set which we have uploaded and display the first 10 rows. What information is contained in this data set? So let's enter this and let's see what output we'll get over here. So you can see that we are getting the Python code also here, and you can see here that using this head function, we are getting the output. And parallelly, we are getting the information of all the variables which we have in the required data set, that is car MPG. So first is what we have asked. We have asked to load the data set. So ChatGPT will load the data set, and we were asking over here that display the first 10 rows. So by using this head function, the output will be here, will show you the 10 starting rows of the data. So we are getting the starting 10 rows. Simultaneously, we'll apply this code in Jupyter also, that whether we'll get the correct output in Jupyter Notebook or not. So that also we will check. But as of now, first we'll discuss what we are getting as an output over here. So now, as we can see, we are getting starting 10 rows. Now we're going to understand the whole data set. So this complete car MPG data set is having 10 columns, 10 variables basically. First is MPG, miles per gallon, that is fuel efficiency. Then after cylinder, that is CYL, number of cylinders in the engine. Then after this, that is engine displacement, which is in cubic inches. Then HP, that is horsepower. Then WT, that is weight of the car, which is in pounds. After that, ACC, that is acceleration, second required to reach 60 mph. Next is YR, that is model year, as a 2-digit number, example 70 to 1970. Basically 1970 over here, it would be 70. So next is origin, that is origin code. It might represent different region or countries. Then after car type, that is type of car for which we are doing this analysis. So type of car, example 0 might represent one category and 1 might represent another. Car name, the last variable, that is name of the car, which basically include make and model. Now, this data set could be used for various analysis, such as understanding the relationship between fuel efficiency and other attributes, or classify car based on their characteristics. Here, what we will going to understand, we're going to understand the relationship between fuel efficiency and other attributes. Okay, so let's try this code in Jupyter as well. Let's see that whether we are getting the output there or not. So when we copy this code, you can copy directly from here as well. When you click over here, it will get copied, and then you can paste this code in Jupyter Notebook. So you can see I have already pasted the code. I have uploaded the data set over here. I have given the data set name, which should be in CSV format over here, because we are using the command read_CSV. So if you are uploading the data set, which is with the extension of CSV, then there you have to use this command, that is pd.read_CSV. And then you can see that we are getting all these column names over here. Now, the next is over here, you can see that we want to check the starting first rows. So what code for that? So basically here we have this code, that car mpg_data.head. So when I paste over here that code, let's see what outcome we'll get over here. So here we are getting what? First is this one, that whatever the code we have at last, computer will display that only. So here the last code is .head function we are giving, and based on that we are getting starting 10 rows, because head function is basically give starting 10 rows. If you want to see more rows, just enter the value inside the bracket. So if I want to check, let's say 20 rows. So if I enter here I'm getting 0 to 90, that means 20 rows data. So head function is basically what? To display the number of rows based on the value what you are giving inside the parenthesis. Now, next is what? So next is to display the data type of all the variables from the above data set, because we want to know the type of the data which we are using in the data set. So for that, we'll ask ChatGPT by using this prompt. You can give any prompt as per your ease. So as of now, I am giving over here that display the data type of all the variables from the above data set. So when we enter this prompt, we'll get some output. So let's see what we are getting over here as an output. I'm getting the code also, which is in Python, car_mpg_data, which is the data frame name, and .dtype. Dtypes is the function basically used to understand or used to get the output based on data type. So you can see here we are getting the result that first variable is of float, another is of integer, another one is again float, one is of object, that is HP, that is horsepower. Then after weight is of integer data type, and so on. So here you are getting a complete explanation also, and the data type of the variable in the car MPG data set are as follows. So here we are getting all these complete explanation. What next ChatGPT is showing here is, it's worth nothing that HP column is of type object, which might indicate some irregularities in the data, such as missing value or non-numeric entries. If we need to perform numerical analysis on this column, we have to clean and convert it to the numeric data type. Now, why we are getting this? Because if you want to perform analysis and if the analysis is numeric based, so in that case, we have to convert that. And if you are converting a variable into some other data type, before that you have to check whether we have missing values or not. So for that, we will going to apply some other code there, and let's see what output we'll get at that stage. As of now, we are skipping this part because any which ways we're going to check whether we have missing values or not. And during that process, we'll check this column as well to understand whether how to impute the missing values or not. So yeah, here we are checking all the columns and simultaneously we are checking the type of the data. So this is the final output. If I apply this code in Jupyter Notebook, let's see whether we are getting a correct output or not. So already we have over here this code. I'll paste it over here. When I will run this code, so after applying this code, we can see that we are getting the output, and here what we are getting as an output, we are getting all the type of the datas based on the code which we have given here. So MPG is float data type, cylinder is of integer data type, same HP is of object data type, and so on. So yeah, this is correct. And as of now, whatever we are getting code through ChatGPT showing the correct output. Now let's understand the next step. So now the next step is, if you want to check is there any duplicate rows. So that is also a very important step during analysis. Duplicacy should not be there, missing value should not be there. So as a prompt I am giving here, display the duplicate rows from the above data set using Python. Why we are specifically mentioned over here Python? Because we want Python code as of now. So that's why we are specifically mentioned here using Python. When I enter this code, I'm getting some output. Let's see what output we are getting. Okay, so as a code, what we are getting over here, that finding basically here, first we have to create a variable, obviously. So the name of the variable in which the output will get stored is duplicate underscore rows. And we are getting the code over here that from the data, car MPG data, get the duplicate values. So for that, we are using here duplicated function. You can see one parenthesis over here. So if a parenthesis is there, that means that is a function. So with duplicated, we have a parenthesis. That means duplicated is a function which we are applying on the data, and that basically take out all the duplicate values. We'll show you complete duplicate values, whatever we have, whatever duplicate values are present in the data set. So when it will get stored to duplicate underscore rows, then we will call that variable and we'll get the output. As an output here, what we are getting, that empty data frame. Columns are these many columns, whatever we have already in the data set. And as an interpretation, as a final result, what ChatGPT is showing here, that the car MPG data set doesn't contain any duplicate rows. All the entries in the data set are unique. There is no duplicacy. So we can go ahead with this data set as of now. If you have any specific questions, so you can ask. So now I really want to check whether we are getting the same output when I apply the same code in the Jupyter. So when I copy this code, I'll paste over here. Let's see what output we'll get. So there is nothing. Basically, we do not have any duplicate rows. Okay. Let's go ahead with other step, and we'll apply one more prompt here. Now the next prompt I'll give over here is display the categorical and continuous variable in the dataset using Python. Why? Because I want to know that how many categorical variables do we have here, how many continuous variables do we have here. When I enter this prompt, let's see what output we are getting. Okay, so as we have asked over here that display the categorical and continuous variable in the dataset using Python, we are not asking what is categorical and continuous, but still we are getting output based on the explanation that ChatGPT is giving over here is that categorical variable are those that can take on one of limited set of values representing categories or labels, while continuous can take on an infinite set of values within a range. Based on the data type and the nature of the variable, we can identify categorical and continuous variable. So categorical variables are basically what? Variables that are typically integer or object type and represent discrete categories. And continuous is basically what? Which are typically float type and represent continuous measurement. So now here you can see the code based on the prompt what we have entered. So categorical variable ChatGPT has created in which we are storing the output, and output based on what? That select data type include object int. So we are asking if the values are of object and integer, store that column names in this variable, that is categorical variable. If the variables are of float data type, then store those column names in the form of list, because here you can see that we are giving a code that to list. So basically the columns will convert to list, and that will get stored where? In continuous variable basically. Okay, so now here removing the column that are known to be continuous but are represented as integer, that is year. So categorical variable dot remove year from the list. Now when we display, when we ask a categorical variable and continuous variable, what we'll get as an output? This is the output. So based on the data type and context, categorical variables are these many are the categorical variables, and these three are continuous variable. Because based on continuous and categorical, we'll perform the data analysis. Let's apply this code once and let's see what output we are getting in Jupyter Notebook. Okay, so first is categorical. So first list is based on categorical variable. The another one we are asking here continuous variable. So the another list is what? Of continuous variable. So we are getting a correct output over here. Let's understand the next part of data analysis. Whether do we have missing values in the data set or not? Or if we have, then how to impute that missing values? Because if we have missing values, that will impact the final outcome. So if you have missing values in your data set, so you have to impute those missing values with some other values. Like how, that we'll understand after this. Okay, so the next one is plot the distribution of the origin variable. How does the origin affect the other feature in the data set? Let's understand this also. When I enter this prompt, we are getting an output. The origin variable in the data set is likely a categorical variable representing different region or countries of origin for the cars. We can visualize its distribution using a bar plot to show the frequency of each category. Once we have an understanding of the distribution, we can further explore how the origin affects other features in the data set. Like why we are using this feature overall in the data set and how it is affecting. So this is the bar chart and showing the distribution of car origin. So 1, 2, 3, as we have three values in the origin variable, and first is 1, others 2 and 3, and the frequency here we are getting as on y-axis. The bar plot above shows the distribution of the origin variable in the car MPG dataset, and it appears that the three values are there, and with the name 1 followed by origin 3 and origin 2. So origin 1 has higher frequency, then origin 3, and then after origin 2. Let's explore how the origin affects other feature in the dataset by summarizing some key statistic for numerical variables, and how we'll understand that. There is complete explanation. We'll come back to this code also. So now here you can see we have applied mean function, and we actually want to know how this variable is impacting. Okay, what is the importance on other variables? So MPG origin 3 has highest value fuel per efficiency, so miles per gallon. So origin 3 has the highest mean value, followed by origin 2 and origin 1. So highest will be origin 3. This suggests that the cars which are from the origin 3 are generally more fuel efficient. If the cars are from origin 2, so they are comparatively with origin 3 less efficient, and the origin 1 has the least value. So the cars which are from the origin 1 comparatively with origin 3 and 2 have less fuel efficient cars. Okay, so next is cylinder displacement and horsepower. So cars from origin 1 have high range value, and other one is car from origin 2 and 3 have a smaller engine with few cylinders and lower horsepower. That's how this origin is important for understanding the other features. Based on different origin, we have different values of each column, and that we are getting through this summary. So how we are getting this summary? By using this code. When we apply this code, group by origin.mean function. Mean function will give the mean value of origin, and column wise, the other column wise, here you can see MPG of origin 1 is 20, cylinder is 6.2. So the highest value of miles per gallon is for origin 3, then after 2, and then after 1. We have already discussed what does it mean. Let's copy this code from here and apply, and just check that whether we are getting the output. Yes, we are getting the correct output, what we were getting through ChatGPT. And that's how we can understand that the distribution of the origin variable and how this variable affect the other features in the data set and the importance of this variable. So thank you. So now we're going to understand whether do we have missing values in the data set or not. So for that, first we'll ask ChatGPT by using this prompt that identify and handle any missing values in the car MPG data, and how did you choose to handle them and why. Let's see what output we'll get over here. So we are getting an output. I want to know what code ChatGPT will display over here for that if we have missing values. Okay, so now let's understand this part first. To handle missing values, we first need to identify whether they are in the data set or not. Once we have found them, we can decide on an appropriate method to handle them based on the context of the data. So if we can remove those missing values and it will not impact the whole data set, like because of removing the values from the data, if it is not impacting the main data set, then we can remove. But if we remove the missing values related rows and if it impact the data set, then there we have to use some process that is called imputing the missing values, and that can be done by using some relevant code. But here first is what common strategies we have for this type of issues is removing rows that I already discussed, that deleting rows with missing values if they are few in number and if they are not impacting, like if we remove the values and they are not impacting the main data set, then we can remove. Filling with mean and median. So filling missing values with the mean or median value of the column suitable for continuous variable. Next is filling with mode. Filling missing values with the mode most frequent value of the column suitable for categorical variable. Using interpolation, interpolating values based on surrounding data suitable for time series or order data. So basically here what we do if missing values are there and if we do not want to remove those rows which contain the missing values, so we'll impute those missing values with mean, median or mode value and then we can proceed further. Here let's understand whether do we have the missing values in our data set or not. So for that we have a code over here, missing values summary equal to car mpg data dot is null. Is null is the main function to check whether do we have any missing values or not. Suppose if we have 5 missing values in one column, so that will get sum up by using sum function, and the final total number of values for a particular column will get displayed as an output that will store in this variable which we have created over here, and when we call this variable we'll get the final output. So this is the main code. Based on that, what ChatGPT is showing over here as a result is 0, means we do not have any missing values in the columns. It appears that there are no missing values in the car MPG dataset as indicated by the summary above. However, we previously noticed that horsepower, that is HP column, has an object data type which might indicate some irregularities in the data, such as non-numeric entries. So let's investigate this column to see if there are any unusual values that need to be handled. So we have already discussed about this column, that column is of object data type. This column also we have to check that whether this column has a missing value or not. If this column has a missing value, so we have to work on it. So the code related with this is this one, same. And if in the object data type any missing values is there, so we'll impute those values. So here as an output we are getting a question mark is there in the column. That means that particular row doesn't have any value. Those rows have only question mark instead of any appropriate value. It seems that HP column contains some question mark, that character which likely represent missing or unknown values. These values are not recognized as null or NaN. So we need to handle them. Given that here what we are getting is in output that HP is a numerical variable representing horsepower. Obviously horsepower basically should be a numerical value, but a common approach is to replace them unknown values with the median value of the column. So let's proceed with replacing the character with HP column with the median value of the known horsepower values. So how to convert? See, first is this column is of object data type, but in general we know that horsepower should be of numerical because the values are in numbers, and if we have any column which showing numeric values but the data type is different, so there we have to convert that column with the correct data type. So we have already done over here with apply function. Okay, next is this is the complete code. What we are doing over here is we are imputing the missing values with the median value. So when we do that, then after in HP also we are getting 0 because now we have filled those unknown rows or missing rows with median values of HP, and because of that we are now having no missing values present in the data set. The missing values in the HP column have been successfully handled, and how it got handled? With the median value of the known horsepower values. That median, mean, mode, how we get these values, that we'll understand after this. So now there are no missing values or unknown values in the car MPG dataset. Now I chose to handle the missing values in this way because here ChatGPT is giving the reason also that why ChatGPT chose to handle missing values in this way, because replacing with the median preserve the central tendency of the HP distribution. The median is less sensitive to outliers. Basically, outliers are which is very different from the main values what we have in the column. Let's say HP only. So if we suppose have A, B, C, D, E values in one column, all of a sudden if we are giving their Z, right? So that is very far from the continuous series what we have in the column, right? So that Z will consider as an outlier. So here the median is less sensitive to outliers. So it provides a more robust estimate for filling in missing values. Since horsepower is a continuous variable, using the median is a suitable method for imputing missing values. So that's how we can impute, but again, we're going to check whether Based on this code, we are getting the correct output in Jupyter Notebook also. So let's copy this code first. I'll copy and I'll paste it here. So now, here we are getting the output based on this code that we have missing values, and that missing value basically what, in rows we have some values with this type of character, which is not a value, which is not anything. It is completely unknown value. And now we have to impute this. So based on this type of character, we'll not get a correct prediction. So the next code for that is to impute this value. So when I paste here, we'll run this code. We are checking that missing values after handling. This variable contain all the column names from the data set, and will show you whether we have any missing values left or not. So here we are getting all the names of the column, and parallelly we are getting over here the number of values if missing values are there. So no, there is no missing value because we are getting as an output 0. This is the output what we were getting in the ChatGPT also. So that's how we can impute the missing values if we have any values which is unknown in the data set, and how to impute that we have already discussed. We'll now move ahead with another step. So let's understand the new step for data analysis. So now we have covered till now univariate analysis, bivariate analysis. We have seen that summary statistics, and we have checked that what data set is all about. Everything we have discussed till now. Now we're going to apply a model on the data set to predict the fuel efficiency. So here I'm using a prompt using the car MPG data, build a regression model to predict fuel efficiency. What feature did you include and how well does the model perform? When I enter this prompt, as I'm going to building a model on my data set to predict the fuel efficiency. So building a regression model to predict fuel efficiency involves selecting features. So before we discuss the regression model over here, we'll ask ChatGPT that why we are using here regression model. Okay, when I enter this, I'll get some output. Let's discuss that also. Regression model are used to understand and quantify the relationship between dependent and one or more independent variables. So one would be target variable on which we're going to do the prediction. So here, which one is the target variable, which one is the independent variable, that also we'll discuss. Now we are using here regression model because of some reasons. First is nature of the dependent variable, that is MPG. MPG is the target variable. We're going to predict the fuel efficiency over here. So that is the target variable. The target variable MPG is a continuous numerical variable. Regression model are designed to predict continuous outcome, making them a suitable choice of this problem. Now, exploration of relationship. That regression model allow us to explore the relationship between target and features, quantify how changes in features like weight, horsepower, cylinder affect fuel efficiency. So this is the best model to predict the final outcome based on the target variable. So these all are the reasons. In summary, basically why we are using regression is for the car MPG data set, that with the nature of the problem, the characteristic of the data and the goal of the analysis or prediction, it provides a statistical framework for understanding how various features of car influences the fuel efficiency, offering both exploratory insight and predictive capability. So in short, we can say that as the variable is continuous variable, so in this case we should use the regression model. That is the best model through which we will get the correct prediction based on our data set. Now we're going back and understand the output which we are getting through this prompt using the car MPG data, build a regression model. Building a regression model, here you can see that how many features we have selected. We'll consider the following feature, and these all are the independent variables, and one would be the target, that is MPG over here. This feature include various aspects, okay, and which influence actually the fuel efficiency. That means the target variable. These all are the independent variables, and they actually somewhere or somehow they are influencing the main target variable. That's why they all are comes under independent, and the target variable would be then MPG. Data pre-processing, after that we're going to split the data into features and target. Means one would be X and the other target would be Y. We're going to split that target variable from the independent variables and then further divide it into training and testing set. Then we're going to build the model. So we'll use a linear regression model, a common choice for predicting a continuous outcome variable. As we have already discussed this, let's start. How we're going to do that? There is a code for that. There are required libraries which you have to import first. Then only you will be able to split the data into training and testing, and you will be able to modeling the data set. So this is the complete code for that, and based on that we are getting this result. Now the thing is, we'll discuss this code step by step. We have imported all the required libraries as we are using linear regression model. So we have to import linear regression model from this sklearn.linear model library. Then after train and test split, why we are importing this? Because we're going to split the data into target and the independent variable. Then after from sklearn.metrics, we're going to import mean squared error and R2 square, because we'll check the accuracy of the model. So here we have splitted the data set into X and Y. X will contain all the independent variable and Y will contain the target variable. And then we'll split these data, and after that we're going to create and training the linear regression model. So we will apply this linear regression function. We'll store that in the model variable, and on this model variable we're going to fit the X train and Y train. Y train has the target variable value, and X train will have the independent variable values. Here the Y-pred variable consists the testing set on which we're going to predict. So this is all about how to apply the code, what to do to get the final prediction, and at last we're going to calculate the performance metrics, that how this model performed, and that we can understand by using MSE and R square values, and we are getting the final output. Let's discuss one by one the final result. Mean squared error is 7.25 and R square is 0.8652. So what is the interpretation based on this model? The mean squared error is what? Represent the average square difference between the actual and the predicted variable. The trend data set X train and Y train has actual values, and predicted values what? Based on test. So a lower MSE indicate a better result, better fit of the data, and MSE of 7.25 means that on average the model predictions are off by the square root of this value and approximately 2.69 mpg. R squared over here is what? Is a measure of how well the model's prediction match the actual data. Means what actual data we have, if it is getting matched with the prediction, how well it is getting matched. So it's based on while we check the R squared value. Here the value is 0.8652, that is 86.5%. So that approximately is what? The variation in MPG explained by the selected feature. So this is R squared, this is MSE, we have already discussed. Conclusion is what? The model shows a relatively good fit to the data. If you are getting higher value of R squared by 86%, that means your model performed well. And feature includes what? Cylinder displacement, and these all are the features. Based on that we were predicting the target. We already know that is MPG. The model could be further improved and validated through techniques such as cross validation and all, if you want to improve your model more. As of now, by seeing these values, R squared, the performance metrics, we can come to the conclusion that the model shows a relatively good fit to the data, explaining a significant portion of the variation in fuel efficiency. So this is all about the modeling of data, and we have discussed this part, but through ChatGPT we were discussing. Let's apply this code in Jupyter Notebook, and let's see that the output what we are getting here is same in Jupyter Notebook also. So when I enter this I'm getting the same output, and this is the final output. Here also you can compare, right? So this is all about the data analysis of the car MPG data set. One more prompt I'm going to enter here. You can see analyze the feature importance in the regression model. What features have the most influence on fuel efficiency and why? So based on the interpretation, if you want to know that which feature is having the importance and which actually somewhere influencing the fuel efficiency, which one has the highest value based on that influence. So we're going to check this by using this prompt that analyze the importance of features. And how we're going to do that? Feature importance, basically we generally check just to understand the prediction what we are getting there, which particular feature or which features having more impact on the target variable. So here, if you can see the code, feature importance, pd.data frame, we are giving feature and coefficient values. One column would be of feature and another would be of coefficient. This coefficient, by seeing this value, we can understand, okay, this feature has the highest impact and this feature is actually influencing our target variable more. So out of all these, we can see that the table above shows the coefficient of each feature in linear regression model reflecting their influence on fuel efficiency, that is MPG column. So car type is the most influential feature over here with a positive coefficient 5.82, which indicate that the car with the higher value are associated with high fuel efficiency. So this value is somewhere influencing this MPG variable more. Then after comes 1.49 coefficient, that is of cylinder, and then origin, and the least is weight, a small negative influence indicating that heavy car tends to have slightly low fuel efficiency. So this has the negative influence. So why we want to check the importance of features? Because we should understand that which feature has high impact on the target variable. And the conclusion over here is the feature car type, cylinder, origin and year seem to have the most significant influence on the fuel efficiency, and based on that we can work. And the interpretation of this coefficient should be done with caution, as the nature of the variable, potential multicollinearity and other factor can affect the coefficient. So this is the final analysis, that features in our data set, how they are impacting the main target variable. And this is the way we can analyze the data. And the last step we're going to perform now, we're going to apply this code also in Jupyter to check whether we are getting the correct output or not. When I enter this, the output what we are getting here in ChatGPT, we are getting here also. So that's how you can analyze your data, whatever you want to analyze. You can easily do that by using ChatGPT. It's so easy to understand because you are getting the code also, and you can see that I was parallelly applying the same code in Jupyter and I was getting the correct output there also. So it's very easy to understand, and with that it's very easy to get the complete explanation also here. If suppose somewhere if you stuck that what is the meaning of particular function or a particular code, that also you can easily understand using ChatGPT. So it actually make your data analysis process easy and very understandable. So that's how we can analyze the data using ChatGPT. Parallelly, you can apply this code what you're getting through ChatGPT in other notebook like Colab or Jupyter, just to check whether you are getting the correct output or not. And one thing I can add over here is we should play around with ChatGPT. Like we can explore more also here. These all are the steps of data analysis using Python. And if you want to know more concept based on the output what we are getting, that also you can explore by asking or by applying or by adding prompts in the ChatGPT. That makes your data analysis journey more easy. So yeah, this is all about how to analyze the data using Python code through ChatGPT. Thank you. So now, as we were continuously discussing about missing values, how to impute missing values with median we have to impute, or we should impute with mode, or mean. What is all about it? Mean, median, mode. What is these values are? So we'll understand this by using this prompt. We'll get to know. So the prompt which I'm going to enter over here is display the Python code for summary statistic for the numerical variables in the car MPG dataset in a tabular format. What insight can you gain from this statistic? So let's see what is summary statistic is. Here, as we are getting the output, so we can use describe method in pandas to obtain summary statistic for the numerical variable in the car MPG dataset. This method will provide us with the count, mean, standard deviation, minimum 25th quartile, median 75th quartile, that is Q3, and maximum for each numerical variable. I know it's a bit confusing for you, but we'll understand these all terms step by step. Here we are getting the code to get the summary statistic, but we do not know what is basically summary statistic is. So that we'll ask first to the ChatGPT, and then we'll come back to this part. We are getting the complete output based on the prompt which we entered over there. But let's understand first what is summary statistic is. So we'll ask ChatGPT that explain summary statistic. So now, first we'll understand all the terms what I was saying here, that mean, median, mode, standard deviation and all. Summary statistic, we'll understand this part and then we'll go back to that code. So here, summary statistic provide a concise description of the main aspect of the data set, particularly for numerical variables. Obviously, because if you want to check the mean of the column, it should be a numeric value. Then only you will get the mean, median or mode. So this help in understanding the distribution, central tendency and dispersion of the data. Such a heavy term. So we'll understand this first. What is central tendency? What is dispersion of the data? What next we are getting over? Let's see that also first. So the commonly used summary statistics are count, which will count what? The total number of non-null observation in the data set. It helps in understanding the size of the data set and identifying any missing values. Mean, the arithmetic average. Median is the middle value that is specify the higher half from the lower half of the data set. Now the next is standard deviation, a measure of the dispersion or spread of the values. A high standard deviation indicate greater variability, while a low standard deviation indicates that the value are closer to the mean. Minimum, the smallest value in the data set. Maximum, the largest value of the data set. Data set basically will show you like for each column. Now the percentile. This percentile will divide into three parts: 25th, 50 and 75. 50 is basically what? This one. The 25th percentile, that is Q1, is the value below which 25% of the observations fall. And 75th percentile, that is Q2, in which the value below which 75% of the observation fall. And in between, we check the median value, that is 50%. So now the range is the next one, the difference between the maximum and the minimum value. That is called an idea of the spread of the data, like how the data is spread. Next is interquartile range, that is IQR. It is also a difference. So what is this? Basically the difference between 75th and 25th percentile value, representing the range within which the middle, that is 50% of the value, falls. It is a robust measure of spread that is non-affected by outliers. Next is mode, the value that appears most frequently in the data set. This mode median we have already studied in mathematics. Same meaning is over here also. Next is variance. Variance is the average of the square difference from the mean. It's another measure of dispersion with the higher value indicate greater variability, variance means what, that also you can ask. If you're still confused, so you can simply just ask, explain in detail. So we'll give over here as a prompt that explain variance in detail. When I enter this, here I'll get what? Variance is a statistical measure that describes the spread of a set of data points within the data set. It quantifies how far individual number in the data set are from the average and thus provide insight into the overall variability of the data. So how we calculate, that is another thing, but here basically we'll get all these values in the summary statistic. So now let's go back to the code, and here we are getting the output. We are getting the output for each column. We are getting count, we are getting mean. Count is basically the sum, okay? Count means total value basically. Here count is what? Let's understand this. What ChatGPT is showing, the total number, okay, of non-null observation in the data set. So now here we have count, mean, standard deviation, min 25%, 50%, 75%, that is Q1, and 75 is Q3, max value, minimum value, and so on, right? So let's understand this particular code, that whether it's giving correct output in Jupyter Notebook or not. When I will enter this here, I'm getting the complete summary. This is the complete summary, that is the complete statistic of our data set, which is showing the minimum value, minimum or maximum value, min, that is average, standard deviation, like how the data is deviated. So these all are the statistic. Next is why we always check this. As you know that we have one column over here, that is HP. So when we were checking the missing values, we found that this column has some missing values, and we cannot remove those rows because will impact the data set if we remove. So what we did there, we imputed with median, right? So by seeing this statistic, we can come to the conclusion that like with which value we can impute those missing values. So there we imputed the missing values with median. We can impute with average value, that is mean also, or median as well. Now, as of now, we have discussed the statistical summary of the data set. Now let's understand the next step, which comes under data analysis. So this is the summary statistic. Now we'll check what output we are getting here in terms of explanation. So first column is MPG, ranges from 9 to 46.6 MPG. The average fuel efficiency is around this, that is mean value. Standard deviation is 7.8, indicating the variability in the data set. Same, there might be some high fuel efficient cars, and the maximum value of this particular column is 46.6. Same, we are getting the interpretations based on the other columns, that is cylinder, displacement, horsepower, weight, acceleration, year. So now here is origin also we have, which is a very important column, and we have horsepower is also an important column. So we can see that we are getting fair enough outcome based on the prompt which we have given over here for ChatGPT, and we are getting the correct output as well because we have already checked in Jupyter Notebook. So let's understand the next step that comes under data analysis. Thank you. So now we'll understand how all the variables are correlated with each other by using correlation matrix. So when I give this prompt that create a correlation matrix for the car MPG data, will show you the relationship between all the variables. Because that also we have to understand ki when we increase one variable, that what is the impact on other variables, how they all are correlated with each other. When I enter this prompt, let's see what output we are getting here. So here first is correlation matrix, provide a numerical summary of the linear relationship between pair of variables. It contains correlation coefficient that range from -1 to 1, -1 indicating a negative linear relationship, 1 indicating a perfect positive. Basically, when we are getting the graph in upward direction, basically that means that is positive linear relationship. Negative means that because of 1 the other values is getting decrease. 0 indicating that there is no relationship between the variables. So when I check the code over here to get the correlation matrix, there is a function which we have to apply on the data set. The function name is over here is CORR, that is core function, which will give you the complete summary, of what? Of how all the variables are related with each other. And you can see that we are getting over here the result, and the result is that first MPG and this year, these are related with 0.57. Negative, basically if like yearly this value is getting decreased. So let's understand this complete statistic, whatever summary we are getting here through ChatGPT, MPG and engine characteristic. So here you can see this is the complete relationship, and let's understand step by step. MPG and cylinder, strong negative correlation, which means that MPG and the cylinder variables are negatively correlated. More cylinders associated with low fuel efficiency. MPG and displacement, strong again negative correlation, which means large value of displacement leads to lower fuel efficiency. MPG and horsepower, again the strong negative correlation, which means high value of HP column associated with the low value of MPG, that is fuel efficiency. Same when we compare MPG and weight, strong negative correlation. Heavier car tends to have low fuel efficiency. Means the weight of a car, if it is high, if it is more, so that will tend to low fuel efficiency. So the value of MPG will get decrease. So that is why here the correlation is strongly negative. Next is cylinder displacement, horsepower and weight. These variables are strongly positive correlated with each other. Because of one variable, the other variable is getting increase. So more cylinders typically means large displacement, will give high horsepower and greater weight. Acceleration and other variables, negative correlation. Acceleration and MPG has positive correlation. Cars with faster acceleration tends to be more fuel efficient. Then after air and MPG, moderate positive correlation, because here you can see the value is 0.58. So these all are text based analysis, right? What if we want to see this through a chart? Like how to visualize this correlation matrix through chart. So let's ask the ChatGPT itself, like how to visualize this correlation matrix, and how we're going to ask this. So now if we want to visualize this summary statistic, which is coming in the form of numbers, if I want to visualize using a chart, I don't know which chart I should use over here to visualize the whole data. So I'll ask ChatGPT itself that visualize the above output of correlation matrix using an appropriate chart. Let's see what outcome we'll get over here. So for visualizing the correlation matrix, heat map is the best chart, and it's the best way to visualize. So here you can see that heat map is an excellent way to visualize correlation matrix, as it allows us to quickly identify the strength and the direction of the relationship, whether it is negative or positive correlation, and whether correlation is there or not. So that we can easily understand. And stronger correlation will have more intense color, with positive correlation typically shown in one color, example over here is blue, and negative correlation in another. So let's see what output we'll get over here. So this is the code to generate the heat map, and this is the output based on that code. So you can see that this is the final correlation matrix using heat map. The heat map above visualizing the correlation matrix for the car MPG dataset, providing basic understanding of the relationship between all the variables. And you can see that if I compare this cylinder and car type, negative correlation. If I compare cylinder variable, or let's say MPG, so if I compare MPG variable with cylinder, again it is a negative correlation. And let's see which one is the positive one. So the positive one is this one, origin and car type. It is positively correlated. And if the color code is dark, that means they are highly correlated, either negative or positive. If the color code is light, so they are correlated but not strongly correlated. So here you can see that HP and this disk. So here it is related, how it is correlated, 0.9 with 0.9. So there is a high correlation. So that's how we can understand the correlation matrix. We can visualize the correlation matrix using heat map. So this is one way to visualize correlation matrix. Let's apply this code. Let's understand this code when we paste this in Jupyter Notebook, and we'll see whether we'll get a correct output or not. So when I copied this code over here, I'll enter and let's see whether we are getting the output. Okay, we are getting an error. Correlation matrix. Okay, so here it's showing an error. Why? Because we are calling here directly the variable correlation matrix. We are giving as a variable over here based on which variable you want to display the heat map, and I'm giving a correlation matrix. Correlation matrix, computer here, the notebook is not getting any variable with the name correlation matrix. So first we have to check the previous code. Here you can see that we have stored all that correlation summary, that is statistic, in this variable, which we were not defining in the notebook. So obviously we will not get an output. So first I will copy this code. When I'll copy and paste over here, then we'll sure get an output. Let's see. So here first, by using this correlation function, that is CORR, we'll store the complete statistic correlation matrix in this variable. And when we call this variable in heat map, so we'll get the complete chart based on the correlation matrix of our data set. So this is the complete output what we are getting over here. That means the code what ChatGPT is generating is giving a correct output. Now the next step is to perform the univariate analysis. Here we have seen that how all the variables are correlated, how they are related with each other. Is there any relationship? If it is there, then how the relationship is, and what type of relationship, negative or positive. So that we all already discussed. Next is to understand the analysis between all the variables. Univariate analysis and bivariate analysis we're going to understand. First, we'll cover the univariate analysis. Now, the next prompt over here is, what is univariate analysis? First, we'll understand what is basically univariate analysis. Like, I know what is univariate, but if a learner is analyzing a data set for the first time, that person should know what is univariate analysis. So, first I'll ask ChatGPT that what is univariate analysis, and then provide for the above data set that analysis and visualize using appropriate chart. Let's enter this prompt and understand the output. Okay, so univariate analysis is basically what? Uni means one. So is a type of statistical analysis focus on single variable. So if you want to analyze all the variables, that comes under univariate. If you want to understand the relationship between two variables together, that comes under bivariate. Bi means two. So univariate, basically, if you want to understand or if you want to visualize a single variable, so we'll use various plots for that. And here you can see for this data set or for any other data set also, we can conduct univariate analysis. First should be on numerical variable and visualize that using histogram box plot or density plot. Histogram provide a frequency distribution of the data, how the data is distributed in terms of frequency. We're going to visualize showing the shape, how the data is spread, and the central tendency. Next is box plot, which will offer a visual summary of the central tendency, that how the data is spread, whether it is normally distributed or it is left skewed or right skewed. So that I'll discuss, and as well as the potential outlier, whether do we have an outlier in the variable or not, that also we can understand using box plot. The density plot is another way to perform univariate analysis. So let's see here. This is the complete code. Based on that, we'll get an output, univariate analysis of all the variables. So here we are getting histogram. We are visualizing the data. We are visualizing the variables using histogram. So if I will see this code, you can see here that the code is showing list out the numerical variables, because if we want to analyze the variable, first we have to check how many numerical variables do we have in the data set. We'll list out, and based on that, we're going to use over here for loop, and that loop will actually repeat this code again and again to get the final output, which should be based on histogram, because here what we are giving, that looping through numerical variables to create histogram, box plot, and density plot. So basically we are going to visualize through all these plots. This is the complete code for that. Let's see the output. This is histogram showing you the values are normally distributed or not. So let's see the explanation based on this charts. First is, let's discuss about MPG, miles per gallon, appears to have a right skewed distribution, with most cars having fuel efficiency around 15 to 25 mpg. So let's go to this histogram. So here you can see that it's right skewed, the tail is going towards right, so that's why the name is right skewed, and most of the distribution is towards right. And with most cars having the fuel efficiency, how much? Between 20 to 25 from here. So from 25, so most of between 20 to 25, few having fuel efficiency 45 also, few having 10 also, but most of the fuel efficiency of the car comes under 20 to 25. Next is same for cylinder displacement. Let's discuss about this origin. This is a categorical variable showing the distribution of cars across different origin. Car type binary variable showing the distribution of two different car categories. Now let's discuss one more variable over here to understand this histogram. And right skewed, okay, let's discuss about horsepower. So right skewed distribution indicating that most cars have horsepower in the lower range. So where is that horsepower variable? That is HP here. So you can see the tail over here, it is right skewed, and they are here it's showing that that most values comes under in lower range. Lower range basically 50 to 75, and this is the lower range because here values are very less, but this is right skewed. So yeah, this is the way to visualize the data set using histogram. This visualization provides valuable insight into the individual characteristic of the variable, such as the shape of the distribution, whether the values are normally distributed or not. So now next is we're going to visualize the data set using box plot as well, as we have already visualized using histogram. Second will be box plot. So here why we are using box plot, to understand whether we have any outliers in the data set or not. So for that I have given the prompt that visualize about data set using box plot, and based on that we are getting this output. That box plot, also known as box and whisker plot, is an excellent way actually to visualize the distribution of numerical variable, as they provide information about central tendency, spread, and potential outliers. So you can see here, this is the code, relevant code, and based on that we are getting the output. So few of the variables have some outliers. You can see here these dots, right? These all are what? Outliers, values which are completely different, not different, but if we see that is completely outlier from the main values. I already explained like how different or from the main values. Like if we give in a column 6 values, like 2, 4, 6, 10, and the last value would be, for an example, 100. So that 100 comes under outliers. Okay, so breaking up that sequence, right? So here all values are very nearby, like 2, 4, 6, 8, but that 100 is completely very far from that sequence of that series. So that is a part of outlier. Here we can see that this HP column has outliers, and acceleration, this column also has outliers. So let's see the final result, the summary of this. The MPG, miles per gallon, displays a right skewed distribution with some potential outliers on the higher end. Higher end means here after 50%, basically in the portion of 75th quartile. So now the next is cylinder, shows distinct categories reflecting the specific engine configuration. We were discussing in the box plot about HP, right? Reveals a right skewed distribution with few outliers on the higher end. So higher and lower end is what? 25th quartile is lower, and the 75th percent, that is 75%, that Q3 is the higher end. So in higher end we have outliers. Here also, here we have in lower end as well. So this is the box plot through which we can understand which variables have outliers, and if we have more outliers, so we have to work on that as well. So this is all about to visualize the variables using box plot, and it also comes under univariate analysis. So this is the box plot we have already discussed. Now let's apply this code of this box plot and the histogram, and let's see whether we are getting the output in Jupyter Notebook. So when I copied code from here, let's paste over here and run the code. Are we getting the output? Yes, we are getting all the histogram based on all the variables here. We already discussed. And next, let's apply the code to generate box plot. So simply we have to copy the code and we have to paste in Jupyter Notebook. So here we are getting the complete box plot, and you can see these all are the outliers. Outliers to the higher end. Here also we have outliers in this variable. So this is the box plot.
So here you have multiple levels, and this is what is known as a multi-level inheritance. So here we have 3 classes. We start off by creating the parent class first, and in the parent class we are assigning the name of this person, and then we are showing out the name of the person. Then in the child class we are assigning the age of the person, and we are showing out the age. And as you see, this child class is inheriting from the parent class. Then we have the grandchild class, where we are assigning the gender and we are showing out the gender. And here you see that the grandchild class is inheriting from the child class. So here there are 3 levels. Child class is inheriting from the parent class, and the grandchild class is inheriting from the child class. Now let's go to Jupyter Notebook and implement this. We'll have to start off by creating the parent class. I will have class, I'll have parent over here, and inside this I will create a new method called as assign name. This will have self, and then we will have name over here, and inside this I'll just write down self.name is equal to name. This is how I'm assigning the name. Then I'd have to show out the name, and for that purpose I will have show name. This will only have self over here, and I need to return self.name, and I have created the parent class. Now after this I would have to create the child class. So here I will have class of child. I will create a new method over here, and I will name this method as assign age. I will have self, I'll have age over here, and I need to assign this age. So here it will be equal to self.age is equal to age. Then I would have to show out the age. I'll have to create a new method. This will be equal to show age. I'm writing down self over here, and I would have to return this. So this will be equal to return self.age, and this child class is inheriting from the parent class. So that is why I'll pass in the parent class as a parameter to the child class. Then finally I will create the grandchild class. Here I will have class of grandchild, and this grandchild class will be inheriting from the child class. This again will have two methods. The first method will be assign gender, and this is how I am passing in the two parameters. I'll have self and gender, and here I would have to set self dot gender is equal to gender. Then I will create a new method over here, show gender, and here I will only have self, and I would have to return this. It will be equal to return self dot gender. And now that I have created these three classes over here, I have my parent class, the child class, and the grandchild class. I can go ahead and create the object of the grandchild class. I'll call it GC, and I will invoke it like this. And once I create this grandchild class, I can assign the name, age, and gender. So I will have GC dot assign. Let me write it down again. So here it is GC dot assign name, and the name which I am setting or giving to this person is Bob. Then I'd have to give him some age. So here it will be GC dot assign age, and let's say Bob is 54 years old, and I'll also assign the gender. This will be equal to GC dot assign gender, and the gender is male. I have assigned these three things. Now I'd have to go ahead and show them out. So here it will be GC dot show name, and I am setting the name to be equal to, I don't have to give anything over here, I just have to invoke it, and as you see, I get the name of this person as Bob. Now let me also invoke the age over here, GC dot show age. You would see that the age of this person is 54. Then I will have GC dot show gender, and here as you see, the gender of this person is male. Now we'll start off with this library called as NumPy, which stands for Numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, NumPy should be your go-to language. And this library called as NumPy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first NumPy array. So you can have a single dimensional NumPy array or a multi-dimensional NumPy array. Now we'd have to start off by importing this library. So to import NumPy, we'll type in import NumPy as NP. So this NP which you see over here is known as the alias. So we are importing the library NumPy with this alias NP. Now this NumPy library has a lot of methods, and one method is called the array method. And with the help of this, we will be able to create the NumPy array. All we have to do is type in np.array, and inside this I am passing in the list of values starting from 10 going on till 40, and I'll store it in this object called as n1, and when I print it out I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here, and inside this we have two more lists. The first list comprises of the elements 10, 20, 30 and 40, and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as NumPy. Now I'd have to import the NumPy library. So I'll have import NumPy as NP, and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the NumPy array. So for this, I'll have to use np.array, and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40, and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this NumPy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this NumPy array. So I'll have type. Inside this, I'll pass in n1. And as you guys see, we get the result numpy.nd array. So nd array stands for n dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4. And the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out n2 over here. And I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1 cross 2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros, and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1 cross 2 NumPy array where the values are only zeros. Similarly, over here, I am creating a 5 cross 5 NumPy array where all of the values are zeros. So I'll just use np.zeros, and inside this, I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here, I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this NumPy array. Now if I want maybe a NumPy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 NumPy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3 cross 3 NumPy array which comprises of only zeros. Now if I want to initialize a NumPy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in two parameters. The first parameter is the dimension of the NumPy array. The second parameter is the value which we'd want to insert into this NumPy array. So here we are creating a 2 cross 2 NumPy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 NumPy array where we only have tens. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in two parameters. Let's say I'd want a 4 cross 8 NumPy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 NumPy array where the value is only 5. Now similarly, if I want to initialize a NumPy array within a particular range, then I can go ahead and use the arange method. So here, as you guys see, I am using np.arange, and this again takes in two parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. and when I given 20. So here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skipped value. So the skipped value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement arange method over here. np.arange, and I'll store this in N4. Now I'd have to use np.arange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out N4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this NumPy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a NumPy array with random numbers. And to initialize NumPy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22, and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers. And this will take in 3 parameters. Let's say I would need values between 50 and 100. And I would need 10 random values over here. And let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list, we have 1, 2, and 3. In the second list, we have 4, 5, and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns. And this is what the n1.shape gives us. Now, if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list, I'll have values 10, 20, and 30. And in the second list, I'll have values 40, 50, and 60. And I'm storing this in N6. Now, once that is done, let me just print out N6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have N6.shape. And we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape, and over here I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, headstack, and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20, and 30. Then we are creating the NumPy array n2 where we have the values 40, 50, and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same NumPy arrays over here. And instead of using vstack, I'm using the headstack method. I'm passing in n1 and n2. And as you guys see, 40, 50, and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these NumPy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these 2 NumPy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what will be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the headstack method. So here I'll type in np.headstack, and inside this again I'll pass in n1, n2. And as you guys see, I have stacked n2 at the back end of n1. Now, if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack, I'll give in n2, n1. And I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in n1, n2. And as you guys see, I have n1 in the first column, n2 in the second column. Similarly, if I give in n2, n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the NumPy arrays. Now we'll also work with intersection and difference methods. So here again we have two NumPy arrays. So in the first NumPy array we have the values from 10 to 60, and in the second NumPy array we have the values from 50 to 90. And if I want the common elements between these two NumPy arrays, then I can use the intersect 1D method. So here in the intersect 1D method, I would just have to pass in these two NumPy arrays. And as you see in the result, we get a new NumPy array comprising of the common elements in these two NumPy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1D method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1D, and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the NumPy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the NumPy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect 1D and setDiff1D. I'll just add a comment over here, intersect 1D. And I would have to create two new NumPy arrays. I'll have n1 over here. So I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6, and I'll have n2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect 1D. So I'll have np.intersect 1D, and inside this I'm passing in n1, n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now, if I want only the elements which are common to n1, then I can use the setDiff1D method. So here I'll have np.setDiff1D, and inside this again I'll be passing in n1, n2, and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np.setDiff1D, and I'll just change the sequence over here. Instead of passing n1, n2, I'll have n2, n1, and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1, n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays. And let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array. And over here I'll have 30 and 40. I'd have to pass this on as a list of values. So I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1 comma n2, and actually I'd have to pass this as a list. So I'll have n1 comma n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1 comma n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60, because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40 and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19 and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10 and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array, and inside this I'll have 10, 20, 30 and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35 and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25 and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3 and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if we want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np dot mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another numpy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular numpy array, so I'll pass in n2. And you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic numpy arrays. Now let's go ahead and work with a numpy matrix. So here we are creating a 3x3 numpy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6 and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this numpy matrix, let's see how can we access individual rows and columns from this entire numpy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1, and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this numpy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here. And since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2, and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in numpy matrix over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list, I will have 10, 20 and 30. In the second list, I will have 40, 50 and 60. In the third list, I will have 70, 80 and 90. And I will go ahead and store this in n1 again. Now I'll go ahead and print out n1, and let's see what would be the result. So this is our numpy array which we have just created. Now if I want to access individual rows from this, I'll have to give in n1. And inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write n1. And over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows would be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30, which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have n1, where we have the elements starting from 1 going on till 9. Then we have n2, where we have elements starting from 9 going on till 1. Now, if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So, the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So, it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np dot array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50, and 40. After this, I'll have 30, 20, and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now, if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my underscore NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my underscore NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load. And over here, I'd have to give the name of the NumPy array. So it will be save underscore n1 dot npy. Let me actually remove this over here. And I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result. So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first we'd have to start off by importing pandas, which is the library, and we are giving this alias as PD. So import pandas as PD. Then if we want to create a series object, we'll have pd.series, and inside this I am passing in the values 1, 2, 3, 4 and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task could be to import the pandas library. So I'll go ahead and type in import pandas as PD. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series, where S is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40 and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0, but instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0. 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have 3 key value pairs. A10, B20, C30. So here automatically the keys are taken as the labels, and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1, and inside D1, let me have 4 key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now I would have to create a series object out of this. So I'll just have pd.series, and inside this I'll pass in D1, and let's see what would be the result. So these 4 keys which were present became the labels, and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, A, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30, and D, we had not created any key with this particular index. So that is why we have N, A, N over here. And then we have A, for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is, so instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2, and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I've been extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end, when I given colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8, and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning, and a sequence of elements from the back. Let me just create a new series object over here. So I'll have S1 is equal to pd.series, and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60, and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1, then I'll have colon, and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60, and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, so initially we had this series object where the numbers started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8, and so on. And we can also go ahead and add 2 series objects. Over here, I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here, and these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10. And as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now, also I can add two series objects together. So in this series object, I have 7 elements. I'll go ahead and create S2 where I'll have 7 more elements over here. So I would have to type pd.series, and inside this, let me just have 7, 6, 5, 4, 3, 2, and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a two-dimensional labeled data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now, let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataFrame, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have two key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam, and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25, and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam, and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam. Then we have Annie. Going ahead, we have Jennifer. Now, once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has scored 50 marks, Annie has scored 60 marks, and Jennifer has scored 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame, where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.co.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a dataset called as the iris dataset. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV, and inside this I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns, which are sepal length, sepal width, petal width, and species. And we'll have 3 different species, which would be Setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149, because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which you can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first 3 records. So here, the rows would be 0 to 3, and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1, and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys, so that will be easier for you to have a glance at this. Now, let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2, and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end, because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39. And the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .loc method. And over here, when it comes to rows, you see that I've given 0 to 3. Here, when it comes to .loc, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here, I'm giving in the column names, which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame. Then I'll just go ahead and use this .loc method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20, and the columns which I'd want to extract are sepal length and petal length. I'll just have sepal.length over here, and the next column which I want would be petal.length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the axis value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the axis value to be equal to 0. And if you want to drop a column, then you'd set the axis value to be equal to 1. So if from this entire iris data set, again, I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the axis, which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame, so here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2, and 3, here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2, and index value 3. And the resultant which you see over here, after 0, we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2, and 3, and I'll set the axis to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05. Average petal length is 3.75. And average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean, and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max, and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median, and when I click on run over here, this would give me the median values with respect to all of the columns which are present. Now we will get on with this library called as matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be NumPy, because we would want to create our data with this NumPy library. Then we would import this pyplot submodule from this matplotlib library. So we'd have to type in from matplotlib import pyplot as plt, and the alias which I'm giving for pyplot is plt. Then I'll create two NumPy arrays over here. The first NumPy array will be X, and I'm creating this NumPy array with the help of this np.aRange method, and the range will be from 1 to 10. And then I'll create the next NumPy array, which is basically 2 times of X. So all I have to do is multiply X with 2, and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6, and this is how it proceeds. Now, once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this pyplot module. So this takes in 2 parameters, which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as plt. Let me write the spelling properly over here. And once I've imported these 2 libraries, I'd have to create the data. So first I'll have X, and this I'll be creating with np.aRange, and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out X for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create Y, Y will just be 2 times of X. So here I'll have 2 into X, and then let me print out Y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in X. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in 2 parameters, which are X and Y. So this data would be plotted onto the X axis. This data would be plotted onto the Y axis. And I'll just show this as a result. So as you guys see, we have this object X mapped on the X axis, this object Y mapped on the Y axis, and this is the corresponding line plot. Now that we have created this, we can also add the title X label and Y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add X label and Y label by using these 2 methods. And as you guys see, we have added these 2 labels over here. So let me add the title X label and Y label plt. So I'll copy this entire code over here, and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have X label. So here I'll have plt.x label, and here I'll give the X label as X axis. Then I would have the Y label, so plt.y label, and inside this I'll give the Y label as Y axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the X and Y axis labels. Now with the help of these 3 methods, we have added the title, the X axis label, and the Y axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color. And as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1, so we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2, and this is the final result which we get. So let's go ahead and add some color, line plot and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here, and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line, and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10. But I'll have 2 y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make 2 plots because I do want 2 line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which you are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again we have the title, x label and y label, and we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here, but when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all of the numbers which are present in x. Now y1, I'll set it as 2 times of x, and then I'll have y2, which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this, I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis I'll obviously have x, then onto the y-axis I'll have y1, and the color for the first line I'll have green, and let's say the line width, I'll set this to be equal to 2. Then I'll have the next line which will be between x and y2. So here I'll just write down x comma y2, and for this line I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it will be plt.show, and I would also want a grid over here. So before this I'll set plt.grid, and I will set this to be equal to true. Let's hit run, and as you guys see, I have 2 lines in the same plot. Now in the earlier example, we had 2 lines in the same plot, but if we actually want 2 subplots itself, that is, As you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have two plots over here. And those two plots would be present in this way. So I'll have one row, two columns. As you guys see, I have one row and two columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between x and y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between x and y1. Then we'll have plt.subplot, which is our next subplot, and the first two parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between x and y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have x, y1 and y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between x and y1, and I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot. And the first two parameters will be 1 and 2 because I'd want these two plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2, and over here I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between x and y1, and the color of this line is yellow. The next subplot is between x and y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have two rows and only one column. When I hit run, as you guys see, I have two rows and only one column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of three key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys, and I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in two parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt, and Sam. And on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here. And I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got three key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names, and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now, the plot which we had created earlier was very bland, and we can go ahead and add the title, X label, and Y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the X label and the Y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names on the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now, after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar. And we are adding a color as well. So by default, we had the blue color. And if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red. And we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis, we'll have names. Let me change this to names. And as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities. And these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in X, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have Y, and in Y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter and I'll just pass in x comma y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same X and A. These are the same lists which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot, where we had two lines in the same graph, we can perform a similar sort of thing over here, where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between x and y1. Then I'll go ahead and create the second scatter plot, which will be between x and y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have 2 sets of points over here. The first set of point is being denoted by these small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create 2 subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters. And since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between x and a. So this is the scatter plot between x and a. Then I'll go ahead and create the next subplot, and the next subplot will be between x and b. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1. And the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. A categorical column, but when it comes to a histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times, and the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4. And this is the result which I get. I'll copy this entire thing. I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv, since this is a CSV file. So inside read_csv, I am passing in the name of the file and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column, and I'll set the number of bins, and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small. It'll be petal length, and I'll set the number of bins to be equal to, let's say, 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list. The minimum value will be 4. The maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1. And inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly given 9 numbers. And again, I'll have L3. And also in L3, I'll just randomly given some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these 3 box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the violin plot. So the only difference is to create a violin plot, we'll be using violin plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here I'll just copy this entire thing, I'll paste it over here, and instead of having plt.boxplot, I'll just have plt.violinplot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have 2 lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie, and here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show out the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create two lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. The third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples. I've got 43 mangoes, I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to given the categorical object, so I'm mapping fruit onto the labels. Then I would just have to show out this pie chart, so plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here for this auto PCT attribute, I am using 0.1f. Now what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here I'll have to use %0.1f. Let me add %%. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entities. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5, it is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'd have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4. The radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually. And let me keep this as 1. And this is the resultant donut chart. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset, and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset. And I'm storing this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need pyplot. So I'll have from matplotlib import pyplot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have sns.load data set, and inside this I'll be passing in the name of the dataset, which is fMRI, and I will store it in this object called as fMRI. And let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. SNS dot line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the Q event. This blue color line represents the stem event, and this orange color line represents the Q event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this Q event, you see that the peak is not so high. So for the stem event, it was almost 0.2. And when it came to Q, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal Q, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of Q event is much higher when compared to the increase of the stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the Q event is being represented with this dotted line, and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers. And when I set this to be equal to true, you will see that. So I have markers now. When it comes to the stem event, the markers are solid circles. And when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as PD. Now, once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this, I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this isLegendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this isLegendary column and then the speed column. So I'll be using SNS.barplot, and onto the x-axis, I would have to map isLegendary, and then onto the y-axis, I'll be mapping the speed column. And the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between isLegendary column and weight in kg column. So isLegendary column is again mapped onto the x-axis. It's just that here for the y-axis, we are mapping weight kg column. And this time it is very, very obvious that legendary Pokemons, their weight is much, much higher when compared to non-legendary Pokemons. I'll cut this out. I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column. And we already know to do that, we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have two different legendary status. So 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these two categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary. This denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plot is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette, and we can directly use different predefined palettes. So first we have the Blues D palette with a capital B. This is how it looks like. Then we have the Rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute, and the first palette which I'll be using is Blues D. And as you guys see, this is the Blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the Rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between two numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up, then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got three different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got three different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add two more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis, and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column, and you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses, and for Virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head. And these are the different columns which are present. So I've got carat, which obviously tells us about the carat of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters. And Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot. And since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have SNS dot dist plot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt dot show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here. And I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this. And to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created. And to this, if I want to add color, I'll use this color attribute. I'll assign it red. And you would see that I have assigned it the red color. Now, if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10. And I'm just setting the color to be equal to green. I'll select this over here. I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now, if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here, and here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now, I'll have to use sns.jointplot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'll have to map something. So onto the y-axis I'll be mapping petal.length, and that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Once I have done this, let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company. And on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv. And then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column, which would go on the y-axis, and this churn column, which would go on the x-axis. SNS.boxplot, and onto the x-axis, I'd have to map obviously the tenure column. Onto the y-axis, I am mapping the churn column. Then I'd have to use the data, which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go onto the y-axis and churn will go onto the x-axis. Now, if we get this box plot, and we've already seen the inference, it seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these 3 different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have, or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these 2 boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here. But on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service. And this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have 3 different types of contracts: month-to-month contract, 1-year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2-year first, followed by month to month. Then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here I'll remove the line width, and instead of line width I'll use this attribute called as order, and first I'll have 2 year. After that I'll have month to month. Then finally I'll have the last box which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here I'll add this attribute called as hue, and I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories. So we have an interesting case study now. We have a IPL data set, and we'll be thoroughly analyzing this IPL data set with the help of the pandas library and the visualization library, which is matplotlib. So our first task would be to import all of the required libraries. So what we'll do is we'll go ahead and type in import pandas as PD. PD is the alias for pandas. Then we'll also go ahead and import the pyplot submodule from the matplotlib module. So here we'll have from matplotlib import pyplot as PLT, and PLT is the alias which we are giving for pyplot. And finally, we'll also include one more visualization library, which is Seaborn, and that is why we will have import Seaborn as SNS. Let me just go ahead and click on run, and let's wait for all of these libraries to be loaded. So it'll take a bit of time. So these are the 3 important libraries which we'll be needing to thoroughly analyze this data set. So now that we have loaded all of the required libraries, we would have to load the CSV file. And we have the CSV file called as matches.csv, which has all of the details of the different IPL matches. And we already know that to load a CSV file, we would need to use pd.read_csv. And inside this, we will give in the name of the file, which is matches.csv, and that we will store in this object called as IPL. So now that we have loaded this matches.csv file and we have stored it into the IPL object, let me go ahead and have a glance at the head of this data frame. So I'll have IPL.head, and we also know that the head method gives us the first 5 records of any data frame. So if you see over here, I have 1, 2, 3, 4, and 5. So these are the 5 records, or the first 5 records from this IPL data frame. So let's just look at the different columns which are present in this data frame. We have the ID column, which would tell about the unique match ID. So here each record represents one unique match, or one match which was played between different teams. So here, as you see, the match ID is 1, and this match ID 1 represents that particular match in 2017 between Sunrisers Hyderabad and Royal Challengers Bangalore. Then we have match ID 2, which would represent the match between Rising Pune Super Giants and Mumbai Indians. So this is how, or this is what the ID column tells you. Then we have the season column, which would tell you in which season or in which year this match had been organized or this match was played. So as you see over here, the first 5 records, these represent the matches which were played in the year 2017. Then you have the city over here, in which city was the match played in. So this match between Sunrisers Hyderabad and Royal Challengers Bangalore was played in Hyderabad. Then you have the date column over here, and the date tells you the exact date on which this particular match was played. So this match was played on, so you have 2017-04-05. So this would be 5th of April 2017. So team 1, team 2, this just indicates who were the or what were the two teams playing against each other. Then you have the toss winner. Which team had won the toss? So between these two teams, Royal Challengers had won the toss. And after winning the toss, what did the team decide to do? So here you have the toss decision column. And this column tells you that after winning the toss, Royal Challengers Bangalore had decided to field. Then you have the result column. So in result column, we have 3 categories, and those 3 categories we'll look at them later on. Then you have DL underscore applied. This DL underscore applied tells you if the Duckworth-Lewis method was applied or not. And Duckworth-Lewis method would obviously only be applied if there was rainfall. After that, we have the winner column, which tells us which team has won the match. So this match between Royal Challengers Bangalore and Sunrisers Hyderabad, this match was won by Sunrisers Hyderabad. Then you have win by runs and win by wickets. So this column over here tells us that since Sunrisers Hyderabad had batted first, they have won by 35 runs. Over here you have the win by wickets column. Now you'd have to understand this interesting thing over here. So if a team bats first and wins the match, then it will be winning by a certain number of runs. But on the other hand, if the team batting second wins the match, then it will be winning by a certain number of wickets. So here, since the team batting first has won the match, that is why you have a value in this column and you don't have a value in this particular column over here. Let me give another example to make you understand it better. So let's say the team batting first has scored 100 runs and the team batting second was all out on a score of 75. Then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column. Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit sixes on a well, was the man of the match. Then you have the venue over here. And this match was played at Rajiv Gandhi International Stadium, Uppal. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636,18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method. And that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL, and inside parenthesis, I will give in the name of the column, which is player of match. After that, I will give in the dot operator, and then finally I will use value counts method, and this will give me the frequency. So here, as you see, Chris Gayle, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 man of the match awards. After that, you've got AB de Villiers, who's got 15 man of the match awards. And you have David Warner, who's got 15 man of the match awards, and so on. Now, from this list, I would want to get only the top 10 players with most man of the match awards. So here, the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis, I will give in 0:10, which will give me the 10 players with most man of the match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gayle, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most man of the match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most man of the match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most man of the match awards. Going ahead, what I'd want to do is, I would want to make a bar plot for the top 5 players with most man of the match awards. And if I would want to make a bar plot, obviously I would have to use the matplotlib library. So I have already imported the pyplot submodule from the matplotlib library and have given it an alias of plt. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this, I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, you would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of, or the result or the number of man of the match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator. Then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken The categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of man of the match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner and Rohit Sharma. Now, we had the result column over here. So I would want to know the frequency of the different categories of this result column. And if I would want to know the frequency, again, what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame, and inside parenthesis, I will give in the name of the column. So here the name of the column is result, and I will use the value counts method when I click on run. As you see over here, I have 3 categories: normal, tie, and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the 3 different categories which we have. And out of all of these matches, most of the matches have been done normally. And there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that, you have RCB with 70 and so on. Now, I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match, which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Super Giants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization, and I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7x7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object, and I'll give in parenthesis and given the name of the column, which is win by runs. And I'll have plt.show. So here this is interesting, as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here, so this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very, very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title, and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xlabel, and I'll just write down runs over here. And as you see, the X label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I'd want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first. But then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times, there's a difference of 14 times over here, or 14 wins over here, and that's a huge disparity. Now, what I want to do is, I want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'd have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size and I'll set the dimensions to be equal to 7, 7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that I will give in the keys method, and this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner, value counts 0 to 3. And I'm setting colors for, or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference. But here, this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.pie. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7, 7. And since I would want to make a pie chart, I will have plt.pie. And over here, so the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities, and the second parameter we will give in the categorical values. So the first parameter will have batting first, winner dot value counts. The second parameter is batting first, winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8% and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now, similarly, I would want to look at those teams who have performed well after batting second. Now, for this, we have already seen this. So if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is, the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.hist, and inside this, I will just pass in the win by wickets column. And I am setting the number of bins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this bin over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe, let's say, only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve, and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how, normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very, very few chances for the team to win the match after that. And also, if you look at this, there have been very, very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now, after this, again, I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really, really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind, you have Mumbai Indians who have won 44 matches batting second. Then you have Royal Challengers Bangalore also close behind who have won 42 matches. Then you have Delhi Daredevils who have won 41 matches after batting second. Now, similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7. Then I'll have plt.bar over here. Over here, the first parameter, I would have to set, or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians, and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green. And for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore. And for RCB, I will give in a red color over here so that this represents their jersey color. And as you see, I have changed the color. So Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color. And Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB, who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams. And that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.pi. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4% and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here in 2010, 14 and 16, we had exactly 60 matches played. So this is something which again is interesting. So most number of matches were played in 2013 and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that, you have Kolkata with 61. And now, I would want to do something interesting again. I want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the NumPy library, import NumPy as NP. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now, after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. And this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls, David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match 1. And let me have a glance at the first 5 records of this data frame, and this we have already seen. And I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side. And 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, from this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsmen. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours. We have 9 sixes. There were 9 couples as well. And there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen off the SRH team, and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to 2, match 1 inning is equal to 2, and this I will store in this object called as RCB. Now once that is done, I would want to know the different type number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 622, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught, 2 of them have been bowled, and there were 2 runouts. So here we have the FIFA 20 dataset and we'll be performing exploratory data analysis on top of this dataset. And now we'd have to import all of the required libraries. So we are importing pandas for data manipulation, obviously. Then we have Matplotlib and Seaborn. So Matplotlib is a library which is used for data visualization. Seaborn is also a library which is used for data visualization. So Seaborn you can consider as it's an extension of Matplotlib. Extension in the sense that Seaborn is built on top of Matplotlib. So these are the 3 libraries which I would need. And what I'll do is I'll actually restart the kernel so that you're not able to see the output initially. So for you, it will be much more easier to understand. Now I'll hit on run and let's wait for these libraries to load. All right, so we have loaded the required libraries. Then going ahead, we have this file called as players20.csv. So this is a file which I have already loaded in Jupyter Notebook. And to read a CSV file, we would need this method called as read_CSV. And this method read_CSV is a part of the pandas library. So here, since I have loaded pandas, so I'll write down pd.read_CSV. And inside this, I will give in the name of the file, which is players20.csv, and I will go ahead and store it in this object called as FIFA. And I'll just hit on run. Now, if I would want to have a glance at the first 5 records which are there, so I need to use the head method. So by default, this head method gives you the first 5 records which are there in this data frame. So FIFA.head. And here you would see that you have all of the different columns. So you have the FIFA ID, you have the player URL. So if you would, this is a column which just gives you the home page or the description of this player over here. Then you have the short name of this player. So here you have El Messi, obviously Messi. Long name is Lionel Messi. You have Cristiano Ronaldo and you have Cristiano Ronaldo's long name. You have Neymar, you have Oblak, you have Eden Hazard. And here this column obviously tells you the age of this person. Here you have the date of birth. Then you have the height in centimeters of this player and the weight in kilograms of this player. Then you have the nationality. So Messi is obviously from Argentina. Ronaldo, we all know, is from Portugal. Neymar is from Brazil. Eden Hazard is from Belgium. And these are the clubs for which these folks play. Cristiano Ronaldo, he plays for Juventus. Messi plays for Barcelona. Neymar plays for PSG. Eden Hazard plays for Real Madrid. Then you've got all of these different stats over here. So for now, we'll just leave out those stats. So let's actually see how many columns are present in this particular data frame right now. So what we'll do is I will start a for loop and I would want to know all of the columns which are present. So what I'll write down is for call in FIFA.columns, and I will print out each of the column which is present in this entire data frame. So for call in FIFA.column, so what will happen is it will iterate from the first column. So it will start from this first column and it will go to the last column over here, and we are printing all of the columns which are present over here. So for call in FIFA.columns print of call, when I hit on run, you would see that these are all of the columns which are present. You have FIFA ID, player URL, short name, long name, age, date of birth, height in centimeters, weight in kg, and so on. So you have a lot of columns over here. Now I'd want to know how many records are there and how many columns are actually present in this data frame. So for that purpose, I will use this shape method. I'll write down FIFA.shape and I will hit on run. And you would see that there are 18,278 records and 104 columns. So this is actually a huge data set. For performing a simple case study. So here, 18,278 records would mean that you have a list of 18,278 players in this entire data frame, and 104 columns are just the different features with all of these different players. So we've looked at the shape, and there is this column called as nationality in our data frame. So here, if you go up, you would see that there's this nationality column, and I would want to see how many players belong to which particular country over here. So since nationality is a categorical column, and if I'd want to understand more about a categorical column, I can use the value counts method. The value counts method gives me a frequency count of the different categories which are present. So what I'll do over here is, first I'll give in the name of the data frame, which is FIFA. Then inside the parenthesis, I'll give in the name of the column, which is nationality. Then I'll use the dot operator and use the value counts method. And when I run this is what I get. So you see that in this particular data frame, most of the players are from England. So you have 1,667 players from England. Then you have 1,216 players from Germany, and you have 1,035 players from Spain. Then you have 984 players from France, then followed by 886 players in Argentina. So this basically tells you that in this data set, you have a lot of players from England, and that could also be a reason because you have more number of clubs participating in the English Premier League. So you also have all of these relegation zones. So you have tier 1 clubs, you have tier 2 clubs, you have tier 3 clubs. So maybe this data frame comprises of all of the players belonging to tier 1, tier 2, as well as tier 3. And that could tell you why there are more number of players belonging to England. Then, let's say from this entire result, if I would only want to have a glance at the first 10 records or the top 10 countries where most of the players belong to, what I'll do is I'll write down FIFA nationality dot value counts. And again, I'll just give in 0 to 10 inside this. And when I hit on run, you would see that. So most of the players belong to these 10 countries over here. Again, at the top, you have England, Germany, and Spain. Then let's say instead of top 10, if I would only want to have a glance at the top 5. So over here, I'll write down 0:5. And you would see that I have these 5 countries. I have England, Germany, Spain, France, and Argentina. Now, I would want to make a bar plot for these top 5 countries where most of the players come from. So if I would want to make a bar plot, I would need to use this library called as matplotlib. And we have seen that we have imported the submodule, which is pyplot, and we have given it an alias of plt. So here, first, I need to set the figure size. So as you see, I'm setting the figure size over here, plt.figure, and inside this fig size is a parameter inside this method. And using this parameter, I set the dimensions of the image. And as you see, I set the dimensions to be equal to 8, 5. Now, once I set the dimensions, then I go ahead and create the bar plot using plt.bar. And when I write down plt.bar, you have all of these different parameters over here. So when we are creating a bar plot, the first parameter which we give inside it should be the categorical values. Now, after that, what we do is we give in the numerical entries over here. So what we do is first, if we say categorical entries, these are the categorical values over here. Now, if I only use dot value counts method, that gives me these categorical values along with these numerical values. But what if I only want the categorical values, only the names of the countries? So in that case, what I can do is I can use the keys method. So here, as you see, till here, the command is the same. FIFA nationality dot value count 0 to 5. Then I am using the dot keys method over here, and I will hit on run, and you would see that I am able to extract the names of these top 5 countries without the values. And since I need to pass in categories as my first parameter, this code is what I'm passing in as the first parameter over here. Then going ahead, the next value is the same command without the keys method. Then going ahead, I have another parameter called as color, and I set the color to be equal to green. So G is, again, it's just a short form for the green color. So I have first passed in the categorical entries, then I've passed in the numerical entries, then I have passed in the color over here. Then I hit on run. So here you see that this is the bar plot which we have created, and it's pretty evident, isn't it? This is what we saw in the list as well. So most of the players, they are from England. Then you have around 1200 odd players from Germany. Then you have 1000 odd players from Spain. Then you have France and Argentina falling behind. So right now we have looked at the nationality column. Now we will go ahead and do some more analysis. So we have the wage in euro column. Now I'll just show you if we can. So now as you see, like some of the columns wouldn't be listed over here because this is a huge data frame, but we have this column called as wage underscore euro. So this tells me the salary of these players in euros, and I'd want to see, I'd actually want to see over here which player gets, what is the salary of some of these players. So what I'd want to do is from the entire FIFA data frame, I'd want to extract only 2 columns. The first column would be the short name of the player, and the second column would be the wage in euro. And this I will go ahead and store in this object called as player salary. Now that I have created this sub data frame from my original data frame, then I would want to have a glance at the first 5 records of this. So here, player salary dot head, I will click on run. Here you see that in the first column, I have the short name of the player, and in the second column, I have the salary of the player. And here, as you see, Lionel Messi, his wage is, you have 65,000 euros. Then you have Ronaldo with 405,000 euros. Neymar is at 290,000 euros. Oblak is 125,000 euros. And Eden Hazard is at 470,000 euros. So I'm not sure if these are the latest salaries which these players get, but according to this particular data frame, it would seem that Eden Hazard and Lionel Messi actually get more salary than Cristiano Ronaldo. And now, what we will do is I'd want to see who is the highest paid football player. So from this data frame, from this sub data frame, what I want to do is I would want to sort this with respect to the wage column. So what I'll do is I'll write down player salary dot sort values, and inside this I have this parameter called as by. And what I'm doing is I'm just sorting this data frame with this column called as wage underscore euro, and I'll set ascending is equal to false because I would want that player with the highest salary at the top, and that is how it will proceed. And this again, I'm storing it back in the same object called as player salary, and I'll go ahead and hit on run. Now I will have a glance at the first few records of this. So when I say player salary dot head, so obviously as you see over here, Lionel Messi is the highest paid football player at 565,000 euros. Then you have Eden Hazard at 470,000 euros, Ronaldo at 405,000, Kevin De Bruyne at 370,000. You have Griezmann at 370,000 euros. So quite an interesting analysis, isn't it? So again, we will do the same thing. We will make a bar plot for these top 5 football players with the highest salaries. And since we have these categorical entries over here, we would have to make a bar plot. So you have to understand why we're using a bar plot. So normally whenever we do want to understand the distribution of a categorical entity, that is when we go ahead and make a bar plot. So here what we are doing is first the same thing. We will set the figure size. This time we are creating a bar plot for the players with highest salaries. Here, as you see, first I am setting the figure size. So I'll write down plt.figure. Inside this, I'm setting the figure size using this parameter called as fig size. And I given these dimensions. So the dimensions are 8, 5. 8, 5, 8 is the width, 5 is the height. So I've given the dimensions of the figure. Now, after I set the dimensions of the figure, I can just go ahead and create a bar plot. So to create a bar plot, I'd have to write down plt.bar. Inside this, so in a bar plot, always remember that the first parameter which you given has to be the categorical entries. The second parameter which you given has to be the numerical entries. So here, the first parameter, since it has to be capital, it has to be categorical. What I do is I would have to, so we have a categorical column, we have a numerical column. So obviously it is the names of the players which will be passing in over here. So this basically is your x-axis. So on the x-axis, we would need the names of the players. So I'll extract this particular column. So this short name column is from player salary data frame. So I'll write down player salary, and I given the name of the column, which is short name. And obviously I'd want only the top 5 records. So I'll given 0 to 5 inside this. Then I will go ahead and in the next parameter, as you see, I have a wage in euro. So again, since it has to be numerical, this time I'm extracting the wage in euro column, and I'll go ahead and set the color over here. So color, as you see, is equal to red. Then I will go ahead and plot it out. I will hit on run. And as you see, this is the result which we get. So on the x-axis, we have the names of the players, and on the y-axis, we have the salaries. So Lionel Messi obviously is leading the chart. Then you have Eden Hazard, Cristiano Ronaldo, Kevin De Bruyne, and Annie Griezmann. Now let's say if I would want different colors for all of these different bars over here. So that is something which we can also do. Now let's say instead of just keeping this as red, if I would want different colors, so what I'll do is I'll pass in a list of colors over here. So for Lionel Messi, let's say I given blue color. Then for, let me just keep it small b. So for Lionel Messi, I'm keeping blue color. For Eden Hazard, I'll give green color. Then for Cristiano Ronaldo, maybe I'll give in a red color. Then for Kevin De Bruyne, I'll give, let's make it pink. And finally for Griezmann, let's keep it, let's say, orange. And let's hit run. Seems like we have an error over here. The spelling which I've given is incorrect, so let me just keep pink and I'll hit on run, and as you see, this is the result which we get. So we can change the colors which are there in all of these bars as well. Now what I'd want to do is I'd want to do a simple analysis for the players who belong to Germany. So what I'm doing is, so let's say if I, from this FIFA data frame, if I set the nationality is equal to Germany and I hit on run, I get a bunch of true and false values. So when you have these bunch of true and false values, what does this actually mean? So if you have a false over here, this means that in that particular record, the nationality of the player is not equal to Germany. And if it is actually equal to true, then it would mean that the nationality of the player is Germany. So what I'd want to do is, from this list, I would want to extract all of those records where the value is actually true. So I will take this command and I will paste it again inside the FIFA data frame, and I will store it in this object called as Germany, and then I'll print it out. So I'll write down Germany.head. And if I would want to have a glance at the first 10 records of it, so Germany.head, inside parenthesis, I'll write down 10 and I will hit on run. And this is the result which we'll get over here. So as you see, this is the list of all of the players whose nationality is Germany. And now what I'd want to know is, I would want to see who is the tallest German player. So Germany.sort values, I will use by, and I would want to sort this with the height in centimeters column, and I will set ascending is equal to false. And I would only want to have a glance at the top 5 records, so I would want the top 5 tallest players of German nationality, and I'll hit on run over here. And as you see, so you have Aaron Seidel right now as the tallest player of German nationality. His height is 199 centimeters. Then you have Michael Esser, whose height is 198. You have Lars Unestal, whose height is 198 again. Then you have Dominic. Then you have Lucas. So these are the players with the, these are the tallest players. Then similarly, let's say if I would want to sort these German players according to their weight, I would want to see which player has the maximum weight. So again, this will be similar. I'd have to write down Germany.sort values, and I would have to sort it with respect to weight, and ascending, I'll set it to be false, and I'll hit on run. This time you would see that weight over here, so it's Lucas Woltowiak, who has the highest weight of 103 kgs. Then again you have Lars Unestal, whose weight is 103 kg. Then you have Ralph Farman. Then again you have Michael Esser, and you have Niklas Süle. And then I would want to see who is the highest paid German player. So this time I have the wage in euro column, and I am sorting it with respect to the wage in euro. Ascending is equal to false, and .head method. Now if I show you these players, let's see what are these names. So Tony Kroos is the highest paid German player, and he plays for Real Madrid. So obviously if you're playing for Madrid or Barcelona, you would be paid a lot. Then you have Marc-Andre Stegen, and he plays for Barcelona, so he's the second highest player. And then you have Leroy Sané, who plays for Manchester City. Then you have LK, who plays for Manchester City as well. Then you have Thomas Müller, who plays for Bayern Munich. So top 5 players of German nationality who have the maximum wages. Now, again, what I want to do is I just want to make a simple data frame again. So I just want what I want is I would want 2 columns. The first column should have the name of the player, the short name of the player. The second column needs to have the wage in euros, and I would want to sort this with their salaries. So Germany, from this data frame, I'm selecting only short name and wage, and then I'm sorting this data frame by their salaries, and obviously I'm sorting this in descending order, and I would want to have a glance at the top 5 records. Now, if I click on run, you would see that this is what I get. So obviously, it is Tony Cruz, whose salary is 330,000 euros. Then Stegen has 250,000. Then you have Sane at 195. And at 5th place, you have Müller at 170,000 euros. Now, after this, what I want to do is from the original data frame, I would want to see who has the best rating for his shooting skills. So what I'll do is from the FIFA data frame, I'll extract only 2 columns. The first column is short name. The second column is shooting. And I'll extract these 2 and I'll store them in this object called as player shooting. I'll hit on run and I'll go ahead and sort it again. Now, when I hit on run, you would see that Cristiano Ronaldo has the highest rating for his shooting skills. So he's got a rating of 93. Then you have Lionel Messi, then you have Harry Kane, then you have Sergio Aguero, and you have Quagliarella. So these are the top 5 players with highest shooting skills. Now, similarly, I'd want to see which player has the maximum defending skills. So player defending. So this time from the original FIFA data frame, I'll be extracting the short name, the defending column, which would tell me his defending skills, the rating for his defending skills. I have his nationality, and I also have the club for which this person plays for, player defending. And now I would want to sort this by his defending skills. So obviously player defending dot sort values by is equal to defending, and this has to be in descending order. Then I'll hit on run. So you see that you have Chiellini, who plays for Juventus, and he's from Italy. He's got the maximum defending skills. Then you have Van Dijk. Van Dijk plays for Liverpool, and his nationality is Netherlands. Then you have Koulibaly, then you have Gordon, and you have Hummels over here. So Hummels plays for Dortmund. And then finally, what I'd want to do is I'd want to analyze the list of players who play for Real Madrid. So Madrid is one of the topmost football clubs across the world, and I'd want to see what makes this club so special. I'd want to analyze some of the features of different players over there, and that would be the final analysis for today. So what we'll do is from the original data frame, which is FIFA, I will set the club value to be equal to Real Madrid. So from the original data frame, we are extracting only those records where the value is equal to Real Madrid, and that I'll go ahead and store in this object called as Real Madrid again. Now I would want to see who is the highest paid player in Real Madrid. So Real Madrid dot sort values, and I would want to sort it with respect to the wage in euro column. And when I hit on run, you would see that Eden Hazard is the highest paid player in Real Madrid currently. Then you have Luka Modric. So Luka Modric is the second highest paid. Then you have Tony Cruz, Sergio Ramos, and Karim Benzema. So Eden Hazard plays for Belgium. Luka Modric plays for Croatia. Toni Kroos plays for Germany, Sergio Ramos plays for Spain, and Benzema plays for France. And now we have looked at who are the highest paid players in Real Madrid. Now let's also see who has the best shooting skills in Real Madrid currently. So Real Madrid dot sort values, and I would have to sort it with respect to the shooting column. Ascending is equal to false because again I'd have to sort it in a descending order. And as you see, Gareth Bale has the best shooting skills currently in Real Madrid. Then you have Jimmy Rodriguez, who is the second best shooter, followed by Eden Hazard. Then you have Karim Benzema. Then you have Luka Jovic. Finally, I want to see who are the best defenders in Real Madrid. So Real Madrid dot sort values, by is equal to defending, and I'll hit on run. And here, as you see, so it seems that Sergio Ramos is the best defender in Real Madrid currently. Then you have Casemiro. After that, you have Varane. Then you have Carvajal, and finally you have Militao. So these are the top 5 defenders currently who are playing for Real Madrid. Now, let me start off by running this again. And now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the pandas library. And we have a CSV file called as characters stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now, I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default, this head method gives you first 5 records which are present. Now you see this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abincer, Abomination. Then you have the alignment, whether the superhero is good or, so basically we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So I guess there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abincer, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape, and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now, going ahead, I want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this
parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that, so out of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains, and 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. So let me explain this command properly to you folks. So what I'm doing over here is, so first when I given the name of the data frame, inside this I given the column name. So let me write down alignment over here, and when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here, and if we go up, so we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now when I hit on run, and if you look at this particular data frame over here, so you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again, here you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why you have 3D man at the top. Now, I'd want to see which of these superheroes has the maximum speed. So, speed over here is a numerical column. And if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good.sort values, and I would want to sort this data frame with the help of the speed column. And I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have this speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to, again store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell about this, and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you, so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3, and 4. So again, so you have different versions of Flash over here on the basis of the comic books. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1, and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records, and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be, that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Whiskit, Wandra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good.sort values. So I'll delete min speed good, and over here I'll also delete this. So now from this data frame good, I'd want to this time. So initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good.sort values, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. What do you guys think about that? So now, similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power, and I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame, and I will store in, let's say, I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here, So let me just quit max powerful. And when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V dot shape. And when I hit on run, so you would see we have 33 superheroes who have a power of 100. And that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes, are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Where was that? Sort values, speed. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so seems like Superman does not have a power of 100. So that is something interesting to find out over here. So we have done analysis till tell the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again we will be needing Matplotlib, and Matplotlib again has a submodule called as PyPlot, for which we have given this alias of PLT. Now I will insert a cell above this, and what I want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now, what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power. So you see this total column over here. So I'd want to look at the top 5 list of those who have the maximum total value, right? So here, as you see, Martian Manhunter seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. For in all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. But this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here, and these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is, I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions, and I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8, 5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these three different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5, because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again, 0 to 5, because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have done. And we have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or super villains: Ammo, Amazo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these super villains. So again, it will be bad.sort values. And this time by it will be speed ascending is equal to false. So similar stuff what we've done. And as you see over here, so you see that a lot of these super villains also have a speed of 100. So you have Zoom, Airwalker, you have Amazo, you also have General Zod over here. So then you have Superboy Prime. So all of these super villains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run. And as you see over here, you have Mr. I'm not sure how you spell this, but so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing. Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most, badass of all of these supervillains. So again, I would want to look at the total column over here. So bad.sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amazo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that, how Doctor Strange, who is equally intelligent as Dormammu, who is able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 10,5. I don't know, 10,5 seems fine. Plt.bar. So how to give different colors in the bar. So I'll show you how it's done. So plt.bar, here the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here. And I have plt.show. Why do we have an error over here? Bad max bar. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram. And here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now, on the other hand, if I just want a distribution of speed, so speed is only a numerical column. That is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. Right. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have 2 peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again, I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for supervillains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to supervillains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So out of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. What if I need only some selected columns as an output, not all columns? Sure, I will show how to do that. So let's say from the original data frame, which is Marvel. Now I'll write down Marvel. From the Marvel data frame, if I'd want only the name column and the total column, so this is how I'll do. First, I'll give in this column, the name of this column, then I'll give in the name of this column. Then maybe I'll store it in a new object and I'll call it as Marvel total. I'd have to give in 2 braces over here. Let me cut this out. Let me paste it inside this. Now, let me print out the head of this. So it will be Marvel total.head. And as you see over here, I have extracted only 2 columns from the entire data frame. So you just need to give in the name of the data frame, and inside the parenthesis, so you need to give in 2 braces over here, and inside those 2 braces, you need to give in the columns that you'd want to extract. So this was all about the exploratory data analysis for the Marvel and DC superheroes.
Then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column. Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit 6s on a well, was the man of the match. Then you have the venue over here. And this match was played at Rajiv Gandhi International Stadium, Uppal. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636, 18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method. And that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL, and inside parenthesis, I will give in the name of the column, which is player of match. After that, I will give in the dot operator, and then finally I will use value counts method, and this will give me the frequency. So here, as you see, Chris Gayle, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 Man of the Match awards. After that, you've got AB de Villiers, who's got 15 Man of the Match awards. And you have David Warner, who's got 15 Man of the Match awards, and so on. Now, from this list, I would want to get only the top 10 players with most Man of the Match awards. So here, the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis, I will give in 0:10, which will give me the 10 players with most Man of the Match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gayle, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most Man of the Match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most Man of the Match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most Man of the Match awards. Going ahead, what I'd want to do is, I would want to make a bar plot for the top 5 players with most Man of the Match awards. And if I would want to make a bar plot, obviously I would have to use the Matplotlib library. So I have already imported the PyPlot submodule from the Matplotlib library and have given it an alias of PLT. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this, I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, we would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of, or the result or the number of Man of the Match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator. Then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken the categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of Man of the Match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner and Rohit Sharma. Now we have the result column over here. So I would want to know the frequency or the different categories of this result column. And if I would want to know the frequency, again, what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame, and inside parenthesis, I will give in the name of the column. So here the name of the column is result, and I will use the value counts method when I click on run. As you see over here, I have three categories: normal, tie, and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the three different categories which we have. And out of all of these matches, most of the matches have been done normally. And there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that, you have RCB with 70 and so on. Now, I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match, which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here, between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Super Giants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization, and I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7 × 7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object. And I'll give in parenthesis and given the name of the column, which is win by runs. And I'll have plt.show. So here this is interesting as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here. So this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very, very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xlabel and I'll just write down runs over here. And as you see, the x label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first, but then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times, there's a difference of 14 times over here, or 14 wins over here, and that's a huge disparity. Now, what I want to do is, I want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'd have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size and I'll set the dimensions to be equal to 7,7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that, I will give in the keys method, and this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner value counts 0 to 3. And I'm setting colors for or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference. But here, this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.pie. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7,7. And since I would want to make a pie chart, I will have plt.pie. And over here, so the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities, and the second parameter we will give in the categorical values. So the first parameter will have batting first winner dot value counts. The second parameter is batting first winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f%, which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8% and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now, similarly, I would want to look at those teams who have performed well after batting second. Now, for this, we have already seen this. So if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is, the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.his, and inside this, I will just pass in the win by wickets column, and I am setting the number of wins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this Ben over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe, let's say, only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve, and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how, normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very, very few chances for the team to win the match after that. And also, if you look at this, there have been very, very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now after this, again I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really, really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind you have Mumbai Indians who have won 44 matches batting second. Then you have Royal Challengers Bangalore also close behind who have won 42 matches. Then you have Delhi Daredevils who have won 41 matches after batting second. Now similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7. Then I'll have plt.bar over here. Over here, the first parameter, I would have to set, or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians, and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys, since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green, and for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore, and for RCB, I will give in a red color over here so that this represents their jersey color. And as you see, I have changed the color. So Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color, and Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams. And that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.pie. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4% and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here in 2010, 14 and 16, we had exactly 60 matches played. So this is something which again is interesting. So most number of matches were played in 2013 and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that you have Kolkata with 61. And now I would want to do something interesting again. I'd want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the NumPy library. Import NumPy as NP. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now, after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. And this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match 1. And let me have a glance at the first 5 records of this data frame, and thus we have already seen. And I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side. And 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, from this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsman. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours. We have 9 sixes. There were 9 couples as well. And there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen off the SRH team, and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to match 1 inning is equal to 2, and this I will store in this object called as RCB. Now once that is done, I would want to know the different number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 6-2-2, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught, 2 of them have been bowled, and there were 2 runouts.
So we would have to start off by importing all of the data sets that we need. So we would need pandas, matplotlib, seaborn, datetime, and numpy. Pandas is a library which is used for data manipulation,
Matplotlib and Seaborn are libraries which are used for visualization. Datetime, because we have a column in our data set which is of date and we'd have to manipulate it, so that is why we would also have to import this, and we would need the NumPy library which is used to create and manipulate arrays. So we'll be importing all of these libraries, and this is the syntax for that. So let me just go ahead and click on run. And also guys, I want this session to be very interactive, so if you have any doubts anywhere, please go ahead and put them up in the chat section. I will take up all of your queries. Now let me just wait for all of these libraries to load. This is just taking a bit of time because I've just loaded my kernel. So we have imported all of the required libraries. Now it's time to load the dataset that we'll be working with in today's session. So this is the dataset, which is COVID-19 India.csv, and we have a column called as date, and normally this is of string type, so we'd have to convert that string type into date type. So that is why we have this attribute called as sparse dates, and to this sparse dates column, this sparse date attribute, we will just pass in the column name which is dates, and we will set the day first to be equal to true. Now normally when you're writing a date, so you can either have the day first or the month first, but if we want the day to be first, we'll just have to set this to be true. Now I'll just go ahead and click on run. So we have successfully stored our COVID-19 India dataset in this object called as df. Now let me go ahead and have a glance at the top 5 records of this. And if I want to have a glance at the top 5 records, I need to use the head method. So I'm using this df.head command over here. I'll click on run. And as you guys see, these are the different columns which are present. So we've got date, which obviously indicates the date over here. So we've got date starting from 30th of January, and this goes on till 17th of July. 17th of July was 2 days back, and 30th of January is when it is starting. Then we also have the time over here. Then we have the state or union territory in which the cases have been confirmed. Then we have the number of confirmed Indian nationals over here. So this is basically a cumulative number. So on 30th of January, there was one confirmed Indian national who tested positive for COVID-19. Similarly, on 1st of February, there were 2 confirmed Indian nationals who tested positive for COVID-19. On 3rd of February, there were 3 confirmed Indian nationals who tested positive. And as you see, this confirmed foreign national tells you if anyone who had come from outside a country had tested positive. So all of these cases are 0 when you talk about the dates 30th of January till 3rd of February. So these are the number of confirmed cases. So as you see, during the late January or the starting week of February, the number of cases in India did not really increase a lot. So you have very few cases or very negligible cases back then, and this is the inference which we can draw from over here. Now that we have looked at the basic structure of this data set, we would want to take only some specific columns from this. So from all of these columns, I'd want to take the date column, the state or union territory column, the cured column, deaths column, and confirmed column, which means that I'll be leaving out the S number, time, confirmed national, and confirmed foreign national. So I'll be taking only these columns and I'll be storing it back into this data frame called as df, and what I'll do is I'll also rename the columns. So this, what you see, D is capital, so I'd want to change this capital D to small d, so I'll just name it as date. Similarly, we've got state / union territory, so instead of having state / union territory, I just want it as state. Again, over here you have cured with C capital, but I want C to be small. Then we've got deaths with D capital, I have made D to be small. Then we've got confirmed with C capital, I've made C to be small over here. Let me click on run, and now I'll have a glance at
the modified data set. So as you guys see, from all of the columns, I have selected only the date column, the state column, cured column, deaths column, and confirmed column. Now, these were the earlier cases, but now if I want to have a glance at the cases which, of the latest cases actually, or the recent cases, then I'll be using the tail method, because tail method will give me the last few records from the data frame or the last 5 records from the data frame. So I'll be using df.tail method over here, and as you guys see, the date over here is 17th of July. So this data set which I'm using has the date starting from 30th of January going on till 17th of July. And these are the states. So this is basically so the states are basically, as it goes in the alphabetical order, it starts from A and goes till W. Similarly, the dates, it starts from January, goes on till July over here. And as you see, as of 17th July, in Tripura, there were 2,283 confirmed cases. Then we've got UP, and as of 17th July, we've got 43,441 cases. Then in West Bengal, we've got 36,117 cases. So this is some basic analogy which we can find out from this particular data set over here. So let me go ahead and see if there are any questions. So guys, keep your questions coming. I want this session to be very interactive. Ethel is asking, which algorithm am I using for prediction? So I'll be using the linear regression algorithm for prediction. So in this session, we'll start off with a bit of pre-processing. We'll do data manipulation, we'll do data visualization, we'll do some analysis, and then we'll go ahead and apply the linear regression algorithm. Akash is asking, where did I get the data set from? So this is a free and open source data set which I have got from Kaggle. So you guys can go ahead and get that from Kaggle. Vishal is saying that the screen is not clearly visible. So I believe you must be watching the session from phone, and YouTube has limited the phone's video quality to only 480p. So if there's anyone who's facing the same issue, please let me know. Maybe I can go ahead and change some settings on my end. Jamshid is saying, I do not understand anything in this slide. What is the meaning of Anaconda? So get access to him this way. We'll use Sir Anaconda. Anaconda is basically an IDE for Python, which I'm using over here to write all of this code. I'm just going through all of the questions, folks. Okay, so what I'll do is, you folks are asking me to increase or zoom it, so let me just zoom this a bit. Now, is it better? Just let me know if it's better. I've increased the zoom over here. So Nikhil, going ahead, I'll be predicting for Maharashtra state. So first we'll be analyzing the data of few particular states. It will be Maharashtra, Kerala, and I've analyzed for one another state over here. And then finally we'll be looking at the cases of only Maharashtra. Okay, great. Keep posting your questions. I'll take them up as we go ahead with this session. And for those folks who have just joined in, we've just started the session. We loaded up the data set, and now we're going to do the analysis. And also, folks, if you want to learn more about machine learning and data science, you guys can go ahead and check out Great Learning Academy. You will find the link in the description. And also, if you want to learn through an app, so let's say if you don't have your laptop with you right now, you can go ahead and you can register, you can download the Great Learning app. You can learn all of these courses from over there. So now that I have had a glance at the head of this data set and the tail of this data set, what I'll do is I'll just extract all of those records where date is 17th of July 2020, because I want to analyze the latest cases. So here, as you see, I've got these columns. I've got date, state, cured, deaths, and confirmed. So from all these records, so I would have around 4,213 records. So from 4,213 records, I would want only those records where the value of date is 17th of July 2020, and I am storing it in this object called as today. Now let me just print this out, and as you guys see over here, so date over here, the S number starts from 4179, goes till 4214, and the date for all of these is 17th of July 2020, which is just 2 days back. And we've got this date for all of our states, starting from in alphabetical order, starting from Andaman and Nicobar Islands, going on till West Bengal. And as you guys see, Andaman and Nicobar, till now there have been 180 cases. Then we've got Andhra Pradesh, where we have 3 lakhs, it's actually 38,000 cases. Then we have Arunachal Pradesh with 543 cases, Assam with 19,747, 54 cases, and so on. So it seems like we have not actually managed to flatten the curve, and the cases are actually increasing. So we'll have to maintain social distancing properly. And if you guys have been watching the news, and if you people are from Karnataka, you would know that there has been a lockdown imposed in Karnataka again. For it's a 1 week lockdown, because we have to ensure that we flatten the curve again. So also what the sources state is, and the peak, the number of cases, they're going to peak in maybe August. So we'll have to be very careful, and we'll have to take all of our precautions. So even though you might be young, please ensure that you guys are taking your precautions and you don't go out unnecessarily. So this is our data set where the date is 17th of July. Now, this data set, I would want to sort it in such a way that I want the cases to be in descending order of number of confirmed. So as you see, I have this object called as today, and on top of the object I am using this sort values method, today.sort values, and over here I've got 2 attributes. So I'm sorting this data frame with the confirmed column. This column which you see, I'm sorting this data frame with this particular column, and I set ascending to be false, which means that I'm sorting the data frame in a descending order. Now I'll click on run, and this is the resultant object, which is max confirmed cases. And as you see, as of 17th July, the most number of confirmed cases are in Maharashtra. So we have 2,84,281 cases in Maharashtra as of 17th July, and that's huge. That's a huge number. And then we've got Tamil Nadu, where we see that we have 1,56,369 cases, closely followed by Delhi, where there are 1,18,000. But if you look at this, so the top 3 states, after that if you look at Karnataka, right, so this is an interesting observation over here. Also, so Maharashtra and Tamil Nadu, so the difference in number of confirmed cases is almost 1.3 lakhs. So 2.8 lakhs and 1.5 lakhs. So, it seems that, Maharashtra, the cases have been growing exponentially, and greater measures have to be taken over there. Similarly, if you exclude Maharashtra, Tamil Nadu, and Delhi, you see that there's a stark contrast again. So in Delhi, you have 1,18,000 cases, and then closely followed behind you have Karnataka, where you have 51,000 cases, which is exactly half the number of cases in Delhi. But the problem is, these cases are exponentially growing everywhere, and that is why Karnataka again has ensured that there is lockdown in this period of time, and the number of cases don't go out of hand. So this is an interesting observation over here. Now that we know this, what I'll do is I will extract the top 5 states with the most number of cases. So from max confirmed cases, I'll give this 0 till 5, which will give me the first 5 records, and I will store those first 5 records in this object called as top states confirmed. Now, once I do this, I will make a bar plot for this. So as you see over here, I'll be using the Seaborn library. So earlier I had imported the Seaborn library as SNS. So that is what I'll be using over here. So I'll write SNS dot bar plot. With the help of this, I'll be able to make a bar plot. I've got the x-axis and the y-axis. I am mapping the state column onto the x-axis, and I am mapping the confirmed column onto the y-axis. That is, I'd want to analyze the number of confirmed cases with respect to each state. And the data on which I'm making this bar plot is top states confirmed, and I want the colors of these bars to be determined by the state column. So I'm mapping the state column onto this hue attribute. This hue attribute basically determines the color of the bars, and then I'll just go ahead and show the plot. And this is the resultant bar plot. So as you guys see, we've got states Maharashtra, Tamil Nadu, Delhi, Karnataka and Gujarat, and we've got the number of confirmed cases. So it's very interesting plot, isn't it? So let me just reduce the zoom over here for now. So as you guys see, the number of cases in Maharashtra, they are more than 250,000. This again, there's a stark contrast between the number of cases in Maharashtra and Tamil Nadu, right? Almost 1.3 lakh cases are more in Maharashtra. Similarly, when you compare Delhi with Karnataka, it's almost more than half in Delhi what you find in Karnataka. So this again is an interesting observation which you find over here. Let me zoom this back. So we have had a look at this. Guys, come up with your questions. I'll take up some of your questions now. Abhishek is saying there might be a lockdown 10 till the curve is not going down. Well, Karnataka has already come up with a lockdown. I believe the other states such as Maharashtra and Delhi might also impose another lockdown to ensure that the cases don't go out of hand. So Nikhil, I'll be using linear regression for this because we'll be predicting the number of cases, which is a numerical quantity. Shika is asking, is the data clean? Not really. So this is since this is a live session, I can't cover everything in this. So I'll be doing a bit of basic pre-processing and basic visualization. I'll not be taking care of cleaning the data set in this live session, but you guys can, I believe if you have registered, you will find the link for this, for the code file. You can go ahead and download the code file, and you can tweak the code as you want and clean it if you want to work by yourself. So Darshan is asking, what are the dependent and independent variables in this data set? So we'll come to that. So for now, I just like to say that the dependent variable would be the number of confirmed cases, and the independent variable is the date. So we will be trying to predict the number of cases on the basis of date. So let's say if I'll say if it's 25th of July, I'd want to know the number of cases on 25th of July in Maharashtra. So that is something which we'll be trying out going ahead. Rajwamsi is saying video is lagging a bit than audio. Is that the case with everyone? Let me know. If again, if that's the problem, I'll maybe go ahead and make some changes in the settings. Rajesh, you can find the data set from Kaggle. If you're not able to find this data set, it's an open source data set. Even though if you're not able to find it, we'll add the description for this data set in the description once the video is done. Vidya is asking, please give us a description of system requirements from running Python. Vidya, to answer that, Python is not, it doesn't really require heavy resources. Basic 4 GB laptop with a 4 GB RAM and maybe 500 GB hard disk should be more than enough. Even a 4 GB RAM and i3 laptop will be more than enough to run Python. It should not be a big deal. Avish is asking what other algorithm can we use. So this would depend on what would be a dependent variable. If you're using a numerical column, then you will go ahead and use linear regression. If your dependent variable is categorical in nature, you would have to use a classification algorithm. So that will totally depend on what is the analysis that you would want to perform over here. So Darshan is asking, is the date time feature a string value or date time object? So in the column, the date column is string in nature, so we are converting that into date time. So that is why we would need the date time library. So when you pass any column into date time, that the string gets converted into the date time object. Right, so I'll take up the rest of the questions later on. And again, folks, please go ahead and subscribe to our channel and hit the bell icon, because we'll be putting a lot more effort for all of our live sessions and it would encourage us a lot. So our only request is to hit the subscribe button, click on the bell icon, and we'll ensure that your lockdown is as productive as possible. And also, if you want to learn more about data science, AI, machine learning, statistics, or digital marketing, you can go ahead and check out Great Learning Academy, the link for which will be there in the chat. And also, if you want to learn through an app, you will be able to learn from the app, for which the link is also there in the chat. Right, so we have analyzed the number of cases with respect to different states. Now, this was the number of confirmed cases. Now, what I want to do is, I'd want to sort this data frame with respect to the maximum number of deaths in each state. So here, on top of the today data set, I'll be using sort values method, and I'll be sorting the data frame with the deaths column, and I'll set ascending is equal to false, because I'd want the number of cases to be decreasing. That is, I want the states with maximum number of cases at the top of the data frame, and I'll store this in this object called as max death cases. Now I have done this, so let me go ahead and have a glance at this. So as you see, the maximum number of cases are in Maharashtra, and also the maximum number of deaths are in Maharashtra. Then it is closely followed by Delhi, Tamil Nadu, Gujarat, and Uttar Pradesh. Now let's again make a bar plot for this. So I'll extract the top 5 states. I'll be using max death cases, and when I pass in 0 to 5, it will give me the top 5 records. I'll store it in top states death object, and again I'll make a bar plot for this. So SNS dot bar plot, state is mapped onto the x-axis, deaths column is mapped onto the y-axis, and the data is top states death, and the color of this bars is again being determined by the state column. Now let me compare this particular bar plot with this bar plot over here. So first, the number of confirmed cases is maximum with the number of death cases in Maharashtra. But if you look at others, so we've got, for confirmed cases, we've got Tamil Nadu, Delhi, Karnataka, and Gujarat. But it seems that the number of cases, so here when it came to confirmed cases, Tamil Nadu was at the second place. But when it comes to deaths, you see that Delhi is at the second place. So this again is an interesting analogy over here. And also if you look at this, Uttar Pradesh was nowhere. So Uttar Pradesh, when it came to confirmed cases, it was not present in the top 5 states. But when you talk about the number of deaths, it seems that Uttar Pradesh is at the 5th place. So this is again interesting. So you see that even though the number of cases is not, the number of cases in UP are not as much as the other 4 states, but it seems that there are more number of deaths in UP when compared to other states with those number of cases. So you can call it per capita death of the number of cases. So that seems to be high in UP. So interesting analogy over here. And now that was the number of confirmed cases, number of death cases. Now we'll do a similar sort of visualization for all of those cases which have been cured. So on top of the today dataset, again I'll be using sort values method, and I'll be sorting the dataset with the cured column. I'll set ascending is equal to false. Let me see this. So here, as you see, the number of deaths are maximum in Maharashtra, the number of cured cases are maximum in Maharashtra, and also the number of confirmed cases are maximum in Maharashtra. Again, quite interesting. So then we've got Tamil Nadu, Delhi, Gujarat, which were also there in the top 4. So the top 4 don't really change. Maharashtra, Tamil Nadu, Delhi and Gujarat are always there. Then we've got Telangana over here suddenly. So it seems that even though the number of deaths and number of confirmed cases are not so much, but the number of cured cases are a lot. So it seems that maybe the Telangana government is doing something better than maybe these 4 states over here to maybe cure all of those patients who've been contracted with the COVID-19 disease. So once we have this, I will extract the top 5 rows again. So max cured cases, I'll have 0 to 5. I'll store this in top states cured. And again, I'll use SNS dot bar plot, and I'll be making a bar plot where state is mapped onto the x-axis and cured column is mapped onto the y-axis. And the data which I'm using is top states cured. And again, the color of the bars is being determined by the state column. As you see, Maharashtra at pole position again with number of cured cases, closely followed by Tamil Nadu and Delhi. This time you see the number of cured cases in Tamil Nadu and Delhi. They are almost similar. Then you have Gujarat over here. Again, there is a very stark contrast. So in Delhi, the number of cured cases are almost equal to 1 lakh over here. But in Gujarat, the number of cured cases are 30,000. So this falls down. The number of cured cases falls down very steeply over here. Then you got Telangana, which was not there in the first 2 graphs. You've got a new entrant over here. So come up with your questions. I'll take them up again for the next 1 to 2 minutes. Paninath is asking, can the video be revised after the session is over? Yes, the video will be available as it is once the live session is done. You can come to our channel again and rewatch the video. Yes, Radhakrishna, the recording will be available for later reference. Abhishek, the code file, you will find the link over here in the chat. You can get the code file from that particular link. And if you want the dataset you can get it from Kaggle. So this is an open source dataset. It's a CC0 dataset, which is available for free for everyone. And if you don't find the dataset, we will add the link for it anyway after the session is done. Abhishek is asking, in df.head, is it taking by default first 5 rows? Yes. If we just use the head method, it gives us the first 5 rows by default. If we want to change the number of rows which we want. So let me just go up over here. So df.head, let's say if I give the value as 10. So as you guys see, I've got 10 records over here. So by default, if you do not give a value, you will only get 5 records, and if you give a value, you will get those many records. Sudarshan is asking, can we use time series? Yes, ARIMA models can also be used for this, but we'll be using a very simple linear regression method so that all of the folks who are new to Python and new to machine learning can understand what is happening over here. Sumit is asking, is basically saying that he wants to learn how to write a program. So Sumit, we've got a comprehensive Python tutorial, and we've got comprehensive tutorials on C, C++, and Java. You can pick up whatever language you'd want and get started with that. So just let us know if you face any problem over there. Sumit is asking if I want to learn how to write a program. I've already answered that. Vishal is asking which model is best to predict. That would depend on what the problem statement is, and also would depend on your domain knowledge. So let's say if your dependent variable is categorical in nature, then you'll go ahead with the classification algorithm. And also, it's not that you will just apply maybe just one classification algorithm. It's not that you'll just apply maybe a decision tree or a random forest and then you'll just let it be, and then you'll just say that this is my final algorithm. What happens is it's an iterative process. First, you'll apply decision tree, then you'll apply random forest, then you'll apply naive Bayes, and you'll compare the results of all of these algorithms and find out or compare the accuracy of all of these models. So I'll just show you where I've got this data set. So just write down Cricket World Cup dataset, Kaggle, and click over here. And let me just open this particular link over here. Let me see if this is the right link. This is not the right link. Let me just go back again. Right, this must be the link if I'm not wrong. Yes, right. So just type in Cricket World Cup data, Kaggle, and this is the these are all of the data sets which I'm using over here. Right now, the data set which I'm working with is this ODI match totals.csv. So you guys can go ahead and download this data set from over here. Let's directly head on to our case study for today's session. So we've got this cricket data set where we have all of the information about the different matches which were played till 2019 World Cup. So we will be analyzing all of those data. So Narasimha is asking where is the data set from. So we've taken this data set from Kaggle. So if you'd want any of these open source data sets, you can take them from Kaggle, and that is where we take most of the data sets which we use for our sessions. Right, so coming to this case study, I'll just quickly import the required libraries. Now, once I import these, I have a certain, I have different data sets which I'll be working with. So I've got all of these different CSV files, World Cup players, ground averages, batsman data, bowler data, ODI match totals, and so on. So now the one main data set which I'll be working with is this. So I've got this ODI match totals.csv, and I'll be loading this by using pd.read.csv, and I'll store it in this object called as ODI total. So now that I've loaded the required library, what I'll do over here is, let's say I also have this data set called as World Cup players.csv, and I'll be loading this as well. I'll start off by having a glance at all of the players who are present over here. So if you see, this players.head comprise of these three columns. I've got player ID and country. So player, we've got the player name, we've got the unique ID for the player, and the country for which this particular player hails from. Then, as you see over here, initially head only gives you the top 5 records. Let's say if I give in 10 over here, I'll get the list of these 10 players. So these are the 10 players who constantly played. So all of these data sets, they have data starting from 2013 going on till 2019 World Cup. So throughout these years, these were the list of cricketers who have consistently played for Afghanistan team. Now, let's say if instead of head, if I give in tail, let's see what do we get over here. So we've got West Indies, and all of these are the players who've played for West Indies. You've got Fabian Allen, Shannon Gabriel, Hetmeyer, Shea Hope, Evan Lewis, and so on. So information about all of these players. And now, from this particular list, so as you see over here, so you've got ID, player, and country. If I'd want the list of all of the Indian players who are present in this particular data frame, I can do that with the help of this particular command. So what I'll do is, first I'll give in the name of the data frame, which is players. Then inside parenthesis, I will give in the column name. So here, as you see, the column name is country. And what I'm doing is I'm giving a condition. I'm making sure that whatever value is present in this column, that is equal to India. So now, let me actually insert a cell above this and show you how this works. I'll have players. Inside this, I'll have country, and when I set this value to be equal to India, you'll see that I have a bunch of true and false values. Now, wherever you have a false value, it would mean that the condition is not satisfied. And wherever you have a true value, that would mean that the condition is satisfied. Now, these true and false values, what I'm doing is I'm just passing them through the data frame again. So when I have players, I cut this condition out and paste this back into the data frame. This is what I'll be getting. So as you see, I've got the list of all of the Indian players. So you've got Virat Kohli, who's the captain of Indian cricket team, Rohit Sharma, who's the vice captain of Indian cricket team, and we've got all of these players who were part of the 2019 World Cup. So we've got all of this information over here. Now, what I'm doing is I'm just taking this command and storing it in this new object called as Indian players. I'll just have this. And now, after we do this, what I'm going to do is I'm going to work with the ODI total data frame, ODI total object which I've created over here. So I'll have a glance at the first 5 records from this ODI total data frame, and I have all of these different columns over here. So this ODI total has different records representing each match which happened between different countries, and you've got all of these different things over here. So this, what you see, this is a match which was played between Pakistan and India. and the score which Pakistan made was 250. So, and who won the match? So if you have 1 over here, it would mean that since in the country column you have Pakistan, this particular match was won by Pakistan. Where was this match played? It was played in Kolkata. What was the date? So date was 3rd January 2013. You've got the country ID. So you've basically got country IDs representing each of these countries. So for Pakistan, it is 7. For India, it is 6. Sri Lanka, it is 8, and so on. And now, I'd want to see all of the matches which were played by India. So again, I'll be doing the same thing. This is the name of the data frame, ODI total. I'll pass in this particular column, which is country. I'll set the value to be equal to India, and I'll store it back to the same object, India again. Now I will run this and I will print this out. And as you see over here, these are the different records which I have. And if you look at this particular column, if you look at the country column over here, you would see that all of the values are equal to India. So now, if I look at this particular, if I'll just explain how it is happening over here. So this particular match was, again, so this was played between India and Pakistan, and India had lost this particular match. So if you look at this and this, so this represents the same thing. So India, Pakistan, you have ODI ID. So this is 3315, 3315. So as you see, Pakistan had made a score of 250 and India were only able to make a score of 165. And they had lost the match over here. And then we've got this particular match. So this was between India and Pakistan again. So this was won by India. And even though India scored only 167 runs, India was able to win the match. Then if we look at, let's say, this particular match. So you've got, so let's say the last 3 matches, maybe before the World Cup, India was playing Australia. So India had lost all of those 3 matches over here. So here, even though India made 281, so Australia had made 314, India was only able to make 281, and thus India lost the match. So here, India set up a target of 358 and also lost the match. Here, Australia set a target of 273. India were only able to make 237 and hence lost the match. So, and these matches, if you see, the last 3 matches were played in Ranchi, Mohali, and Delhi. So this is the sort of inference which you get from this. Now, from this entire data frame, if I'd want to extract only those records where India has won the match, you would see that we have this result column. So I'd have to extract only those records where the value in this result column is equal to 1. And that is what I'm doing over here. So India result is equal to 1. And I will store it in this object called as India win. Then I will print it out. And now if you look at this particular column, you would see that all of the values are equal to 1. So now what I'd want to do is I'd want to understand against which opponent have we won the most number of matches. So you've got this opposition column over here. So I'd want to get a frequency count since this is a categorical column. So to understand these categories or to get the frequency of these categories, we'd have this method called as value counts, and that is what we'll be using over here. So India win, and this particular, so in the parenthesis, we'll just pass in the name of the column, which is opposition. Then I will use the value counts method and I will hit on run. So you would see that during this time frame between 2013 and 2019, India has won 15 matches against Sri Lanka, 13 matches against West Indies, and 12 matches against Zimbabwe. Then, rest you have Australia, 12 matches, South Africa, 10 matches, England, 10 matches over here. So now, if I would want to make a bar plot for this, so we have already imported the PyPlot library, and we've seen how PyPlot works. So first, I'm going to set the dimensions of the image which I'll be creating. I'll have plt.figure. Inside this, I will set this parameter called as fig size, and I'll set the dimensions to be equal to 8, 5. Now, after this, to make a bar plot, I'm just using plt.bar, and I'll explain this command to you over here. So this takes in all of these parameters. The first parameter is India opposition dot value counts 0 to 5 keys. So till here it's the same thing. So this is the command. Now, if I want to make a bar plot for only the top 5 entries over here, what I'll do is I'll have a parenthesis over here, and I'll just give in, I'll set this to be equal to 0, 5. And now if I want only the categories over here, I will use the keys method. So when I give in the keys method, I will only get the categories and I'll not get the values. And this is what I am passing in as the first parameter to this bar, to this plt.bar. Then the second parameter, what I'm passing in is the values. So I'll just remove this dot keys method, and this, when I pass in this, I'll get only 15, 13, 12, 10, 10, and that is what I'll be passing over here. Then I am setting the color over here. So color is equal to green, and this I will, so when I just have color is equal to G, this is what I'll have over here, plt.show. And as you see, I am able to make a simple bar plot out of this. So India has won most number of matches against Sri Lanka, followed by West Indies, followed by Zimbabwe, Australia, and South Africa. So now that we've done this, we'd want to do a similar analysis for the matches India has lost. So for that, what I'll do is I'll have India result, and this time I would set the result to be equal to lost. And this I will store it in this object called as India loss. And again, what I'll do is I would want to check the value counts, India loss opposition dot value counts. And this tells me that during this time period of 2013 to 2019, India has lost the most number of matches against Australia. So India has lost 13 matches against Australia, 8 matches against New Zealand, 8 matches against England, 8 matches against New Zealand. So somehow it would seem that India was able to perform better against the lower ranked teams, and India did not really perform that well against the higher ranked teams. Because if you look at this, India has a lot of wins against Sri Lanka, West Indies, and Zimbabwe during this time period, which maybe, though India has won the matches, but then again, they were quite low ranked during this time period. And if you look at this over here, India has lost matches against Australia, England, and New Zealand, which tells you that maybe they were, the quality of the batting or the bowling from the Indian team was not really up to the mark. And that is why maybe they did not win the 2019 World Cup. So here, I'm going to do a similar plot. First, what I'll do is I will set the figure size, so plt.figure, fig size, and I'll set it to be equal to 8, 5. Then again, I'm making a bar plot out of this. So India loss opposition dot value counts, and I would want to get I would want to make this bar plot for only the top 3 teams over here. So I'll have 0 to 3. And since I want only the categorical data, I'll have Australia, England, and New Zealand. Then if I would want the values, I will pass in the same command without the dot keys method. Then again, I'm setting the color. So now let me just change the color. Instead of green, let me actually make it red. And I am printing out the plot over here. You would see that India has lost the most number of matches against Australia. Then you have England and New Zealand closely falling behind. Now, if I would want to make a pie chart for this, so pie chart will basically give me a distribution of, what percentage of matches have we lost against different teams. So again, I'm setting a figure size over here. So plt dot figure size is equal to 7,7. And when I am making this pie chart, I will have plt dot pie. And when it comes to a pie chart, the parameters what you pass in is sort of opposite of what you do with a bar plot. So here first we'll be passing in the numerical entries, then we'll be passing in the categorical values. So first we will have India loss opposition dot value counts over here. So first we'll get all of the numerical entries, then we'll have the labels. So labels are basically the categorical values. So here India loss opposition dot value counts dot keys. Then to set the percentage values, I will have this new attribute called as auto PCT, and I am setting %0.1 f %%. So this 0.1 will mean that the percentage will be till the first decimal value. And I'll just go ahead and run on this, and you would see that if we look at the overall losses, out of them 26.5% of the losses have come against Australia, 16.3% losses have equally come against England and New Zealand, 12.2% losses against South Africa, 10.2% against West Indies, and so on. So this is how you can create all of these beautiful visualizations. Now, as we had analyzed this for Team India, similarly, we'd want to do an analysis for Australia as well. So now from this ODI total data frame, I'm setting the country value to be equal to Australia, and I will store it back in Australia over here. And now I don't want to do a similar analysis where, Australia team has won. So here, as you see, country is Australia, and you have the result column over here. I'd want to analyze all of those records where the value of result is equal to 1. So Australia result is equal to 1. I'll store it in this object called as Australia win. Then I'd want to see the value counts. You would see that Australia has won 14 matches against England, 13 matches against India, and 13 matches against Pakistan. Now I will again make a bar plot for the top 3 teams against which Australia has won the most number of matches. So the command is pretty much the same, plt.bar. First we will pass in the categorical entries, next we will pass in the numeric values. And this is what we have. So most number of matches against England, India, and Pakistan. Similar sort of analysis where Australia has lost the matches. So Australia result is equal to lost, and this I'll store in Australia loss, and I'll look at the value counts method over here, and you would see that. So if you look at this, so Australia has won the most number of matches against England, and Australia has also lost the most number of matches against England. Similarly, the second most against which Australia has won is India. Again, the second most against which the Australia has, lost is India. So third position, Australia had won 13 matches against Pakistan. Over here, you would see that Australia has lost 11 matches against South Africa. But if you look at this, so it would seem that Pakistan was never really able to perform well against Australia over here. So in this time period, Australia had won 14 matches. So Australia had won 13 matches against Pakistan, and Pakistan had won only 1 match against Australia during this time period. So this is something you will get to know over here. So this is an analysis for the Australian team. And now we'll do a similar sort of analysis for England. So from the ODI total, I am setting the country value to be equal to England, and I will store that in this object called as England. So here, this is what I have. If you look at this country column, you will have England. You'll have result, which will tell you if England has won this match or not. You will have the opposition column over here. And I am setting a condition over here where result is equal to 1, and I'll store it in this object called as England win. Then I'll look at the value count so that I know against which team has England won the most number of matches. So England has won the most number of matches against Australia, then followed by West Indies, then followed by New Zealand. And I'll do a similar sort of analysis where England has lost the matches. You would see that England has, again, so if you see at this, England has won the most number of matches against Australia and also lost the most number of matches against Australia. Then England has lost 11 matches against Sri Lanka and 10 matches against India. It would seem that England is, was not really able to perform that well in the, South Asian subcontinent. So they weren't really able to play that well against India and Sri Lanka. So this is all of the analysis which we have done with respect to today's session.
Here we are in the last section of this session, summary. Let's have a quick recap. What all did we study in this session? We analyzed potential solutions for the challenges related to access quality and technological gaps in Indian education system. In the next project, we will have the knowledge on the regional trends, nutritional value, and the analysis done over the top 10 Indian foods. Then, in the next project, we will understand the pattern in customer ratings and sales trends on top selling books on Amazon. In the next project, we will analyze the demand patterns, peak hours, and busiest locations based on Uber trip data. Insights and extracted summarized data sets is also being created with the help of ChatGPT, and we analyze the same and create the correlation matrix. Player performance and match statistics and seasonal trends in Indian Premier League IPL is also analyzed with the help of Python programming language. Followed by, we also have the analysis on the ratings, team performance, and global ranking based on FIFA data. Later, we compare Marvel and DC characters in terms of powers, popularity, and media presence. Characters, dynamics, alliances, and major events in Game of Thrones series is also analyzed with the Python programming language. Then, we analyze the COVID-19 data set, spread patterns, recovery trends, and mortality rates during the pandemic. At last, win or loss records and performance trends of India, Australia, and England in the Cricket World Cup is also analyzed using exploratory data analysis. Hope this session was informative. Thank you. Happy learning.